dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid galaxy, we see it all. Technological marvels standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive.
Hello community, how are you? Finally, we are at Demo Day, GEO 2026. We have, not too much days ago, a mentor meeting with the managers of Google, and Mary Rodemill was saying that exactly the same phrase I always told to you all. GEO takes a lot to arrive, and then suddenly it passes in no time. Summer goes so fast. So we are in the very last week, and this is the Demo Day video. I have to say that this is a very special year. You know, we are feeling the tsunami, the AI tsunami. You remember that lovely animation that our contributor Kabir did with the AI logo of the Liquid Galaxy with a tsunami. Everything is related to AI this year, for good and for bad. Remember, most of you have used, I would say, a little bit too much AI, but I hope that with the help of your mentors, you've been doing it at least with a stable base. I mean, not just using a tool for doing the work for you, but also using a tool to learn and to amplify your own knowledge. So I have, for example, here the setup of one of the Liquid Galaxies we have at the laboratories, Liquid Galaxy Data Lab, and I'm going to launch a query against one of the systems we developed this year. This is a Liquid Galaxy AI-based Raspberry Pi system. It is not connected, but we have another one. And while I'm talking, I am going to launch to our agent one thing, and let's see later what it does. I'm going to just launch instructions, and we will continue talking. So the screens are empty now. But so we started very long, many years ago, before the pandemic. We did the Drone Ecorio project. It was AI based. We did many. I would say every year we did projects based on AI. But AI has changed a lot this year. It started in 2022 when ChatGPT launched the very first chat, LLM-based chat. But this year, all the, I would say, developers, including new contributors that are learning, are making lots more use of this technology. So it's a crazy, totally crazy day. Take a look. I just launched a query asking to the machine to make a tour against the 10 movies that won the Oscar Awards last year. Automatically, in a few seconds, machine has developed a balloon on the right screen, and it's doing a tour. It's doing a tour about the cities where the main parts of the video were recorded. And I did zero code. I just launched a prompt. So Liquid Galaxy is going to change this year again. We started to change many years ago, but this year we are going to start to change again because AI is changing. This part of code, it will take for you all contributors, I would say, days to make, and also many days for us to test because you did the things on your own virtual machines, but it's not the same that do it for a regular Liquid Galaxy. But the machine has done it. I mean, and I hope you enjoy the video the presentation that contributor Hash did a few days ago with this technology, and I hope you contribute or you participate in the contest we are going to have that we call it skill creation skills for the Liquid Galaxy AI system, this system, because that's crazy. I mean, so we can make visualizations and code, research automatically. The machine does that automatically. So Liquid Galaxy will change again this year, and we have to be there. And before we go to the demos of the 10, sadly 10, we started with 11, but we have one left contributor in midterm. With the 10 rest of contributors that develop their projects in a right way, before we go with the demo day videos, I have to say thank you to many persons. I will start for the people here at the Liquid Galaxy headquarters in Lleida, the many students that are in the laboratories that have helped in plenty of things. For example, designers, people doing video editing, the contributors that do the code and have helped many other contributors to test their applications, Jasmina, Jan, Josep, and so on. And also specifically to Alex that developed plenty of data for some of the local projects, and Paula that did the logos, and many other persons. So thank you for collaborating with us. And then, of course, I have to say thank you to the mentors, because you mentors are great. You develop your own time. You give your own time for free to the contributors and guide them to arrive to this final thing. Take a look. It's making another tour automatically. I didn't say anything. Just the machine started again. It's a tour, so it makes it automatically without saying anything. And what else? So, of course, I have to say thank you to the Google Open Source Project Office, the team behind GSOC. That's Stephanie, Mary, and Lucille. Thank you very much for still keeping it the spirit of the GSOC for many years. 22, I think. 16 for us, for the Liquid Galaxy project. Thank you for organizing. Thank you for still doing most of your efforts. Thank you very much. And that's it. So enjoy the videos, enjoy the presentations, and see you again after a few weeks that we will return doing the activities for the Liquid Galaxy project. And of course, the new whatever stuff the AI and the technology world give us to us. Take care.
I want you to lift me up so high, high, a place that no one's ever been. Take me to oblivion. I wanna feel the dark with you. A place that no one's ever been. Take me to oblivion.
Hi everyone, my name is Shailesh Kumar Shukla. I am from Ghaziabad, Uttar Pradesh, currently pursuing BTech in Computer Science at IMH Engineering College. My Google Summer of project is Liquid Galaxy RPG, a multiplayer pixel art game. The goal of the project is to use large panoramic display into a shared game world where player can join via Flutter controller app. Now let me tell you what I will cover over the next 15 minutes. First, I will talk about why this project is special, then explain you the game and their modes. After that, I will tell you what tech stack and architecture I used in this project. After that, how I utilized AI in this project to work efficiently, then show you the live demo, and then finish this video with sharing my experience and my learning while working on this project. So, start with the first part, why this project is special. Normally, you know that Liquid Galaxy is used for Google Earth tours or data visualization project. My project shows that Liquid Galaxy can also be used for multiplayer RPG based game where one game match is stretched across five screens, and when character is moving from one screen to another, looks very exciting and amazing. And the player can play with their phone and where controller or the Flutter app act as the gamepad. Now let me explain you my game. My game is Liquid Galaxy RPG, a multiplayer pixel art game. The player can play with their phone and the Flutter app act as the controller or gamepad. The game has two modes. One is zombie mode, one is PvP. So here is the map of the zombie mode. It is a cooperative mode where up to four players play together to survive, and enemies will keep coming. The longer they last, the faster they come. And there are also varieties of enemies like goblins, zombies, slimes, rats, and dragon as the final boss. When they defeat the dragon, they will win the match. Then there is PvP mode. Here is the map of it. So there are two teams which try to capture zone A, and the team which hold the zone for longer duration will score more point. When the timer run out, the team which has more point will win the match. So let's start with the section 2, the tech stack. I use Tile for designing the map, Express, Node.js, and Socket.io for the server, Phaser on the client, and Flutter and Dart for the controller. Now let's talk about the architecture. For the controller, I use the clean architecture. The code is divided into core, data, domain, and UI. Domain contains the core business logic. Data handles the server communication and APIs. Core contains the shared communication, shared utilities and configuration, and UI for the interface element. For the server, I use the server authoritative model where server is the single source of truth. Now in this project, the game loop file is the most important file. It runs the game loop. It runs 60 times a second. For every tick, it calculates the game state, where the players are, where the enemies are, handles player movement, run the collision so that nobody walks over the closed wall, and also calculate spawning zombie waves and calculating points in the PvP mode, where which team lose or lost the match. And after then calculating the game state, it broadcast by the WebSocket. Now after that, the second most important part is the game logic. It runs on the client side. There are five different screens and five separate browsers. Every browser share the same game state and load the same map. Every browser, according to their screen number, shift their offset. Now the on the client side, first of all, it listen to the server, uh, then update the visual element like running the player, moving the player from one place to another, attack animation, playing the audio. So you can see that these two files, game logic and game loop generate the game state, and game logic renders on the canvas by the phaser. Now let's talk about path finding, how enemies navigate to the player. So for that, I use flow field approach, where at initialization, every tile of the map is identified whether they are walkable or closed. After that, closed tiles are inflated using this inflate grid method. Like we are adding padding around the closed tile so that enemies do not stuck over the corners. Now for each player, there is created a distance grade using this flood from function. The distance grade for each player. Every tile knows that how far they are from the player, and in the game, when enemy locate their tile, it will look around the surrounding tiles and move toward the tile which is closest to the player. Now you can see that how simple it is, that only a one game state and all of the browsers sharing same game state can synchronize the game across 5 screens perfectly. So overall pro is that you connect to the master in the by the controller, then start the server, and I use some close browser launch browser script so that we can open or close or start the server directly from the controller. You do not have to manually run this script. After that, you open the browser, you connect to the server, and you able to join the game and can play the game. Now let's start with the section 3, how I utilize AI in this project. I used AI in two ways, one as a feature, another as a learning tool. So let's start with the feature. In my game, there are two AI commentators, Cully and Julie, which react to the live game events, like player is having low health, or dragon boss is arriving, or player is holding a zone in the PvP mode. This makes the game alive. Now let us understand how it works. So there is persona.js, which has a build summary function which creates an input. It takes live match state like current player name or their health and their kills, and generate an input. And this input is passed into the generate text function, which is passes this to LLM, and we get a response. After getting the response, we use HTTPS to convert into MP3 from text to audio, and then we play it on the client. So it is really very simple. Now let us understand how I utilize other way. Now let's talk about how I used AI as a learning tool. So when I started this project, I do not know about game development, what is Phaser, how to design a map, and there are a lot of resources in the internet which are. So finding the right resource for my problem is very difficult. So AI uses web search tool which cuts this problem and directly give me the resource which is directly related to my problem. I also used as a coding tool when I do not know how to implement a feature. I can ask it, and also able to understand how it works. So I think AI is very efficient and it makes the learning curve very shorter. Now let me show you the demo of my project. I can go into the loadout and can able to select the character. Also able to choose the power up if I want different. Then I go to home page and click on connect to server. And now I can able to play the game. Now, since it is a multiplayer, let me add a player.
Player and bot 2 are ready for total zombie mayhem tonight.
Survive 3 minutes, then slay the dragon to secure the victory.
18 seconds left. I'm shaking with anticipation for the first wave.
Those 100 health bars won't stay full once the timer hits 0.
Only 6 seconds of peace remains before the chaos begins.
2 players at full health must endure 3 minutes of teeth.
Player is fighting for their life while the clock barely moves.
32 health is a terrifying start with 174 seconds remaining. Curly.
Player is a whirlwind of arrows, but their health is plummeting fast.
Those 12 kills are impressive, Curly, but both players are half dead already.
Silence in the arena, both our heroes are face down in the dirt.
Now let me show you the
Total annihilation, Curly, with 0 health across the board and 0 survivors.
Welcome player and bot 2 to the zone for this clash. Both teams are rushing the circle, my heart is absolutely racing.
Calm down, Curly, 100 seconds remains to break this deadlock.
Look at them staring each other down, the tension is paralyzing.
Neither has earned a point yet with 96 seconds remaining, Curly.
Player is barely standing, but blue is actually holding the lead.
That 10 health won't last long against a fresh bot too, Curly.
Now this is my demo of my project. Hope you like it. Thank you very much. Now let me share you my experience and my learning while working on this project. When I started this project, I was very excited. I thought that everything will go very smoothly, but it did not. There are a lot of problems came while working on this project. The biggest one was the rig itself. The things which work on my laptop does not work perfectly on the real Liquid Galaxy. But later, I was able to fix those issues under the guidance of my mentor Victor and mentor Priyal. There were also some weeks where I was stuck and nothing was working. In those weeks, I learned that it is better to ask mentor directly instead of trying it on my own. I am very happy that I was able to do this project and able to get real world experience. I was able to know about game development, how to work on paranomic display. I also learned about how a multiplayer game works, the screen, the server, and the phone talk to each other in real time. Apart from that, I also able to learn about video editing and improve my communication skills. The mentors were very supportive. They helped throughout the journey. And I want to end this video by saying thank you to my mentors and also to Team Liquid Galaxy for giving me this incredible opportunity.
Hi, my name is Victor Sanchez, and I am one of the mentors for the Liquid Galaxy organization. This year, I had the pleasure of mentoring Sailesh, and we built together the Liquid Galaxy RPG game. This year has been quite special, I have to say. I mean, it is the very first year that we have had AI amongst our students and organization. And we didn't know what was going to happen, to be completely honest. Will the student just generate all the code in a few days directly there? Would they learn something? And well, I'm happy to report that things went much better than I thought, especially with Sailesh. We made clear from the very beginning that yes, AI is allowed, yes, AI is encouraged. However, understanding the code, understanding how the Liquid Galaxy works, and the most important thing, learning about what you are building was mandatory for you to pass and become a successful intern at this year Google Summer of Code. I'm happy to report that Sailesh did exactly that. He used AI in the best of way, starting first, almost asking line by line what the code was doing, then integrating it into its workflow, creating his own tools to understand the code and help himself create a much larger project than he would have done a year ago, where agents were not even a thing. So yeah, the Liquid Galaxy RPG is a great project. It's a really fun game, either with PvP or the zombie mode. Now we are working even further into milestones and objectives, and it was possible, yes, because AI was there, but also because Sailesh took the assignment of just not building something fast, but learning about what he was building seriously. So congratulations, Sailesh. Congratulations, Liquid Galaxy, and thank you one more year to have me as a mentor. It's been a pleasure, and I hope to see you next year. Bye bye.
Hello everyone. My name is Bhumi Shivehri and I am from Agra, India, and I am currently pursuing my BTech in Computer Science at GEO University, Mathura. This summer, I worked with Liquid Galaxy as a Google Summer of Code contributor on my project, EcoGrid Intelligence. The idea behind my project is to understand how climate conditions can affect global energy infrastructure. I built a Flutter application that works with more than 35,000 power plants and analyzes climate data, calculates a climate vulnerability score, and then visualizes those results both in the application and on Liquid Galaxy. I also worked on features like Gemini powered insights and comparison, climate scenarios, and interactive Liquid Galaxy tours. So that was a quick introduction to me and my project. Okay, so I'll start with the overall architecture and then show a few important implementation points. So the user interacts with the Flutter presentation layer. Blocks and use cases coordinate the application while the data layer provides the plant and climate data. That processed data then feeds several parts of EcoGrid. The CBS score and calculation, Gemini Insights, Google Maps, and Liquid Galaxy visualization. Okay, so moving on to my main.dat file, the application starts here. So I initialize the dependencies and application services before starting Flutter init. Okay, so moving on to the dependencies. Okay, so the dependencies are wired through Getit, including the blocks, repositories, use cases, and Liquid Galaxy service. Okay, so I'll start with the power plant dataset because almost everything's begin from this data. So there are more than 30,000 power plants. So one of the first problem was making sure loading the CSV didn't block the Flutter UI. So yeah, so what I'm doing is instead of passing the last CSV on the main thread, I send the work to a background isolate using compute, and uh, The isolate parses the rows and validates the important fields, handles, duplicates, and creates the power plant objects. Yeah. So my get all plans function, in this function, the past result is kept in memory, so I don't repeatedly pass the same data set. Okay, so for the UI, I also use incremental loading instead of trying to display thousands of plans at once. So this files handle all of the things related to this feature. Okay, so moving on to this pre-compute use case, scores can also be pre-computed after a region loads. So risk information is ready when the user interacts with the plans. Moving on to our climate data and caching part. So next is climate data. For each location, EcoGrid retrieves climate information from Open Meteo API, and then yeah, so the response is cached using the geographic location as part of the cache key, and the repository checks the local cache before making a network request. If the cache data is fresh, it can be returned immediately. This is how like the cache is managed. The cache manager distinguishes between fresh, stale, and expired data, so cache information isn't treated as permanently valid. For the global dataset, I added another optimization. Nearby coordinates are snapped to half-degree grid, so plants in the same climate area can share a computation. And I also track requests already in progress. Like if two plants request the same grid at the same time, I don't launch the same computation twice. So there are two levels of optimization: persistent caching for reuse and in-memory grid cache for avoided repetitive work. Okay, moving on to our climate anomalies. So once the climate data is available, the main risk calculation happens here. Okay, so the anomaly engine converts the historical climate data into three stress dimension: temperature, water, and wind. So for temperature, I use the historical distribution and percentile information. And for precipitation, I considered variability, extreme rainfall, and dry days. And for wind, I look at the higher end wind conditions and their frequency. Okay, so these three dimensions have different weights. Temperature is 40%, water is 35%, and wind is 25%. Then I apply a few specific sensitivity metrics because different plants type respond differently to climate stress. So the calculator combines the anomaly values with the plant sensitivity, normalizes the result, and produces the final CVS from 0 to 100 on a scale of 0 to 100. So the score isn't just a weather value, it represents climate stress in the context of the specific infrastructure. Okay, so moving on to the maps, maps and how they are synchronized with Liquid Galaxy. Okay, so now I'll connect the analysis to Liquid Galaxy. So okay. So when a region is selected, the explore block coordinates the operation. So it loads the plans, updates the state, calculates the camera range, and moves Liquid Galaxy to the region where when it's connected. So the region boundary can also be generated separately. So the initial plant loading doesn't have to wait for with that visualization. Moving on to LG service. So LG service is the bridge between the application and the Liquid Galaxy rig. It handles sending the generated visualization to the master or slave screens. So the flow is user action, block coordination, visualization generation, and then Liquid Galaxy visualization. So now moving on to our KML generation part. So this is the KML generation pipeline. Okay, so the bridge between Flutter and Google Earth is KML. So I keep common KML functionality inside KML utils, including document creation and camera movement. So The plant details, right? This is my plant detail balloon builder. So plant details are also generated as HTML inside KML. That means the information can be rendered by Google Earth on Liquid Galaxy rather than being limited to the Flutter UI. And keeping these builders separate means the screen decides what the user wants, while the KML layer decides how that information is represented on the rig. Okay, so now moving to the Gemini part and plan detail. Yeah. So now I'll show the AI flow like how through the plant detail feature. And before calling Gemini, I build a structured context for the selected plant. Okay, so this context contains the plant information, location, CVS, risk level, and the individual temperature, water, and wind stresses, along with variable and available historical scenario information. So we have this generate plant inside use case. So the context then passes through the use case layer rather than the UI calling Gemini directly. Okay, so finally, this service makes the actual Gemini request. The important point is that Gemini receives EcoGrid's calculated context. It is not being asked a generic question about the plant. It generates an explanation from the analysis already performed by the application. I also added a plant comparison as another visualization feature. In this feature, we basically compare different multiple power plants. Okay, so the selected plans are converted into one comparison visualization with 3D markers and connections between them. In this file, I build the comparison balloon KML. So the information screen that presents the plans side by side, including their CVS risk levels and individual climate stress values. And I also have a tour which goes synchronously with the KML balloon. So the same comparison can also become a guided liquid galaxy tour. And so comparison follows the same pipeline as the rest of the EcoGrid analysis, like analysis, visualization, and then liquid galaxy. Moving on to my like final phase. Yeah. So, like coming back to the complete architecture, the whole application is one connected pipeline. So, I'll start with the global infrastructure data, retrieve and cache the climate information, calculate climate anomalies and the vulnerability score. And then that result can be consumed by the UI, Gemini, Google Maps, or Liquid Galaxy. So, the main architectural goal was to keep these responsibilities separated. So, the same climate analysis can multiple features without being rewritten, and that's how the major parts of EcoGrid intelligence connect together. Okay, so now coming to the demo part of the video. So this is how the home screen of my app looks. There are a few quick regions to explore. So first, I'll just connect the application. Settings, then connection panel. I've already entered the credentials, so I'll just start connect. Okay, so as you can see, it is connected. Here the logo appears, and now it will fly to a default location, this pane. So now moving to a region, let's say Italy. So it will start flying to Italy, and here are some filters based on the plant type, and this is the filters based on the risk type. So kind of work like this. Okay, so I'll now try to go to a plant. And here are some data regarding the plant, like historical climate trends. That it is a graph basically that show the trends of the power plant. It will be visible here. Yeah. Same for scenario simulation screen. Here are the few scenarios through which like it determines the projected CVS score. And now I start orbiting the plant. Okay, so it starts orbiting. Now just stop it and go back. Okay, so I also have a compare power plant feature in my app through which you can compare different power plants. I'll just compare these three. So it kind of looks like this. You can see their CVS and climate stress, and also flip them to generate the AI inside. And it is a kind of tool which basically shows the plants that I'm comparing. And this is the grid view. Yeah. Okay, so coming to my experience, my GSOC experience has been really special for me. When I started, I was really excited, but at the same time, I wasn't completely sure what to expect from working on an open source project. So, over these months, I got to experience the whole process of building a project, starting with an idea, figuring things out, making mistakes, getting feedback, and slowly turning it into something that actually works. So, I think one of my favorite parts was seeing the project grow week by week. And in the beginning, even small things like felt like a challenge, but eventually I could look back and see how much had changed and how much I had learned along the way. So there were definitely some difficult and frustrating days, and sometimes I would spend hours trying to understand why something wasn't working, and sometimes I had to completely rethink the way I had approached something. But honestly, those moments taught me more than the things that worked on the first day. And I also really enjoyed working with my mentors. Their feedback helped me a lot, and it also helped me look at my work differently and made me more careful about how I structure and present what I build. And being part of an open source community was a new experience for me. It was nice to know that the work I was doing wasn't just for a college project or an assignment, but something that could actually become part of a larger project. So overall, I feel GSOC had made me more confident as a developer. More than just the technical skills, I learned how to stay calm with the problem, take feedback, and keep improving, and actually see a project through from an idea to a working product. So I'm really grateful to my mentors and the Liquid Galaxy community for all the support throughout this journey, and it has definitely been one of the most memorable experience of my journey. Thank you.
The monsoon flood scenario significantly elevates the risk of operational paralysis at the Akaltera TPP by compromising critical coal handling infrastructure and logistics chains, which are highly susceptible to inundation. This event Grid Intelligence Assessment, ADS Juneta 2. The ADS Juneta 2 facility faces moderate vulnerability due to its reliance. Grid Intelligence Assessment, Agreda Wind Facility. The Agreda facility exhibits a significant vulnerability profile driven primarily by a 71.3% wind stress score, indicating that the site is highly susceptible to shifts in wind patterns and extreme turbulence events that threaten turbine mechanical integrity. Grid Intelligence Assessment, VANDELLOSGR2. As a nuclear facility, Vandellos 2 relies.
Hi, I am Yash, Google Summer of Code 2026 mentor, and this is the video for Bhumi where we have been seeing the very nice EcoGrid intelligence application and me alongside with Siddharth, another mentor besides me, and we have been seeing a very nice application that was delivered this year by Bhumi, and we are still on the very last stages. Throughout the time I saw that Bhumi had a very solid start and also a very nice finish, or if we can call it a finish because we still have to send it to the Go Web Store. But throughout I have seen a very nice neonish application with a very nice tutorial of how the different screen work, how would you understand the different parts, and each of them is very nicely in a very thematic bluish neon color, and I really love the application. Also what I remember is it does use a very nice design system, and it is very consistent throughout of how it is working or what kind of elements does it use. And I really love the way that Bhumi also tackles some of the issues, like we had some problems with how we can make an orbit or some of the other challenges, and throughout the time Bhumi was with her intelligence on the EcoGrid intelligence able to solve them. And we have very nice different map styles and all of that. I would say that yeah, Bhumi has definitely succeeded my expectations, as well as I believe the same with Siddharth and his expectations that we had for this Google Summer of Code 2026 with her contributions. So yeah, I look forward for Bhumi to also be a part of Liquid Galaxy in more higher capacity, keep up the open source contributions, not just to Liquid Galaxy, but in general to the open source. And yeah, that was all about it for the EcoGrid Intelligence. I really love the application. So yeah, thank you.
Hi everyone, I am Siddharth Mudgil, open source mentor at Liquid Galaxy, and for GSOC 2026, I mentored Bhumi Shivari along with Yash Raj on EcoGrid Intelligence project. So there are multiple power infrastructure globally, and these power infrastructure are vulnerable to climate-related factors such as rising temperatures and change in soil moistures. So the whole project focuses on calculating these vulnerability scores and visualize these scores using 3D KMLs, orbits, balloons, and tours on Google Earth on Liquid Galaxy rig. So my overall experience working with Bhumi was very exciting, smooth, and enjoyable. Bhumi was very new to Flutter when the project was started, and she was like very interested in learning and was learning quickly and improving throughout the whole program. I still remember that during our first meeting, she was very nervous. So I made sure that from second meeting, the meeting should be like more like a open discussion rather than me pointing out bugs. And she responded very positively to this. And from the third meeting only, she was actively participating, sharing her thoughts, and discussing different like ways to improve the project, different uh, and like features. And after that, like our meetings developed a very natural and productive flow. We had weekly meetings, and I always looked forward to those because, like, Bhumi usually came up with something new, like sometime very new features, sometime like it was idea how we can improve the user experience or what user accessibility feature. Then, like, although like EcoGrid Intelligence was more of a medium-sized project, but Bhumi proposed multiple valuable features and like I would say impactful also and expanded its scope. One of feature was comparing different power infrastructure or power plants and the UI and user experience for that compare feature was like one of a kind, I think, for Liquid Galaxy apps, and I really like that. And like Bhumi was very easy to work with. She was taking all feedbacks very positively, and she was open to learning and experimenting small features or performance improvement, bringing new idea. And I hope like she continues and be a part of Liquid Galaxy and perhaps return to for like GSOC 2027 as a contributor again or as a trainee mentor. And I hope the best for Bhumi's future.
Hi everyone, my name is Vinayak and I'm from Bangalore, India, and I am a final year computer science and engineering student at Reva University in Bangalore. This summer, as a part of Google Summer of Code 2026 with Liquid Galaxy Lab, I built a project called Rice Farm Agriculture India Visualization. It's a Flutter application that turns the rice agriculture data into an immersive multi-screen experience using the Liquid Galaxy platform. As we all know, rice is one of the India's most important crop, but its production, irrigation, and seasonal pattern statistics are generally locked inside the spreadsheet and reports. So my project takes the data and brings it to life on Google Earth across the entire Liquid Galaxy rig, colored 3D production map, guided narrative tours, irrigation analysis, and real-time camera control, all driven from a single phone using SSH. For the next few minutes, I'll share the live demo on the rig and what I learned along the way, and also my experience in Google Summer of Code 2026. Now I will walk through the implementation of the application, and I will try to focus on the flow of the data through the application, because the important part of the project is how a user action on the phone becomes a visualization of the Liquid Galaxy rig. So firstly, we will move slowly over the left, then we'll go to controllers, services, screens, models, and data folders. So I structured the application into separate layers. The screens are responsible for user interaction and presentation. The controllers manage the communication and the application level operations. The service handles things such as KML generation and text to speech. And while the data and model layer keep the agriculture information separate from the UI. So this separation was important because all the visualization feature eventually communicate with the same Liquid Galaxy controller. So I wanted the screens to stay independent from the low level SSH and KML delivery logic. Then we have this main road dart, so this is the entry point, and then here we have the setting controller, SSH controller, LG controller. So the important design decision here is that SSH controller and the LG controller are created once and then passed into the application instead of creating separate connection inside the individual screens. So basically this means the different feature all operate on the same Liquid Galaxy session. And then we have this run app. So from here my app configures the theme and routes the user into the startup flow, and which eventually reaches the home screen. So then we'll go to the setting controller.dart. So this is so before establishing any connection, I need to check the rig configuration. This is handled by setting controller. So host key, port key, and username, password key, rig num key. So these constants defines the key used in the shared preferences. And the reason I put this logic into its own controller is that the UI should not have to know the configuration is stored. Then we have the save settings here. So first I obtained the shared preferences instance and store the host, port, username, password, and number of screen. And after writing the values to storage, I also update the in-memory fields such as LG host and LG port, so the application immediately has access to the new configuration without needing to reload again. And then we have the load setting here. So when the application starts again, load setting retrieves the values, and I also provide the default for the missing values, so the missing preferences doesn't cause a null value to propagate through the application. And then we have here the clear settings. So this provides an opposite operation by removing the saved configuration. And then we have the SSH controller or Dart. So uh, this is responsible for establishing the SSH connection, executing command, and transferring files from SF through SFTP. And I keep the SSH client and SFTP client as session level objects, and get SFTP. So one optimization I made here was refusing a single SFTP channel instead of creating a new SFTP connection for every upload. So when the get SFTP is called, it first check whether an existing SFTP client is available. If it is, then the section is reused. And then we have the LG controller.dart. So at this point the SSH layer knows how to communicate with the machine, but it does not know anything about Liquid Galaxy visualization. So that responsibility belongs to the Liquid Galaxy controller here. So the controller receives the SSH controller and setting controller through the dependency injection. It also maintains the current number of screen and the state associated with the latest visualization. And then we have the detect screen count. So basically after connecting, we don't rely entirely on the hard-coded screen number. So detect screen count queries the rig configuration and extract the configured number of frames, allowing the application to adapt the actual Liquid Galaxy setup rather than depending on the input from the user. And then we have the safe execute safe query. So basically this is a reliability feature I added here, is automatic session recovery
both safe execute and safe query first try the operation normally, and if the operation fails, then the controller attempts to restore the SSH session and then retries the operation and restore session. So this is particularly useful for a remote hardware environment because a transient SSH failure shouldn't be necessarily terminate the entire visualization workflow. And then we will go to send KML to master. So this is the most important part of the project. When the feature generates a visualization, it eventually calls send KML to master, and I keep the latest visualization in memory and generate the timestamp for the delivery, and the KML is uploaded through SFTP to a hidden temporary file. And then we have the atomic upload. So the reason for using a temporary file is reliability actually. So I don't want Google Earth to refresh file a KML file is only partially written. So the application upload the complete document first and then performs a move operation to replace the file destination. So this gives me an atomic handoff from the upload stage to the file and to that Google Earth is watching or not. And then we have this send KML. So the controller send KML to master. So the controller also maintains an additional synchronization path through the RiceWiz and KML.dxt. So the visualization can be delivered through the Liquid Galaxy synchronization mechanism as well, or the master.kml, which we already have enabled. And then we have the enable master refresh. So during connection, I configure the master KML network link to refresh every 3 seconds, so that the same refresh behavior is configured for the slave machine. And then we have the enable slave refresh. So this is the architecture is essential. So the architecture is essential, phone, then the SSH and SFTP, and then the master KML, and from that the Liquid Galaxy screens refreshes their visualization. So that was particularly important for the colored KML problem I encountered during development. So now we have the KML builder service.dart. So basically now here I have shown how KML reaches to the rig. So I'll show how the visualization itself is generated. So first we have the build production KML. So KML builder service converts the agriculture data into the actual KML document for the production visualization. I iterate over those rice producing states, retrieve their geographic boundaries, and then calculate the relative production intensity. And then we have the max production. So basically the maximum production is used for the reference point. And then we have the intensity and height, then give both the polygon color and its height from the production. So production is not just represented as a number, it becomes an important visual encoding also. So then we have the production tier color. So for the guidance, for the guided rice belt tour, I have also this tier based color mapping. So the production is divided into 4 tiers, moving from lower production to the higher production states. Then we have the build state fly to. So for the individual state, the builder generates a highlighted polygon and label the containing the state information, and a label containing the state information. And then we have the build state blue KML. So this is for the irrigation. The same architecture is reused here, but for the visualization is based on the rainfall and irrigation information instead of the production. So the screen does not need to know how KML syntax works. It simply asks the service for the visualization it needs. So now I will try to connect with the service, and then we have the region screen.dart. So it is a major rice region screen. The user can select a state and the screen call build state flight to KML. So this fly to state, this will first build the KML, then send it to the master, and then it send a lookat query to the position of the camera, and finally show the corresponding dashboard. So basically a single button press results the 3 coordinate action. Firstly, this send KML to master, save query, show dashboard. Then the orbit state here. So the orbit action uses this same separation. The screen asks the KML builder to generate an orbit tour, and the controller handles delivering and playing it on the rig. And at the end we have the tour engine.dart. So for the guided tour, I move the sequencing logic out of the UI into a dedicated tour engine. And then we have the final feature I'll show here. This is the sync navigation. So here I listen to camera movements on the Google map. However, I don't send any network request for the tiny movement event. So instead, I cancel the previous timer and schedule a new updated after 300 millisecond here. So this act as a throttle, and which is very important for the user. Dragging the map can generate a very large number of camera movements at a single time. So now I'll just show the application working end to end. So on the home screen, you can see that the current Liquid Galaxy connection status. The application can restore the saved configuration and stabilization session automatically. So once connected, the controller also prepare the rig for the visualization. So let's start with the main production visualization. So here the application generates the three colored 3D representation of rice production across the major states. The color and the height correspond to the production level actually. So the data becomes immediately visible geographically. So for example, if I select the West Bengal, the application sends the state KML, moves the Liquid Galaxy camera to the corresponding coordinates, and updates the side screen dashboard with the state information. And I can also see a 360-degree orbit around the state. So this gives me more immersive way to explore the geographic visualization. And then we have this voice and narration feature here, this button. So this is basically to add narration for the selected state. So the visualization combines geographic data, camera movement, supporting information, and narration in a single interaction. And then we have the season crop cycle. Here we have the Kharif and Rabi season, and inside each season we have different phases like sowing, which shows the yellow KML, then growing and harvest, and which actually move through these stages. So each state generates its own KML visualization. For example, sowing generates yellow, grow generates green, and harvest generates the orange KML. And it updates the camera, displays the corresponding dashboard showing the stats, and can also be narrated automatically here. This turns what would normally be static agriculture information into a guided visual sequence here. Then we have the guided tour here. So the same architecture is used for the guided tours. So for example, rice belt tour automatically moves through different locations, and each step coordinates the visualization, camera position, dashboard, and narration before moving to the next location. And because a tour has its own engine, I can pause, resume, skip, or stop the sequence. And then we have the sync navigation actually. So finally, this sync navigation, as I move the map up, the application translate the Google Map camera position into the Liquid Galaxy camera command, and this update this throttle, so I don't send a network request for individual movements. So the phone effectively becomes a live remote controller for the Liquid Galaxy cameras. So now I will just try to share my personal experience. So for me, the GSOC project was a really valuable experience. Not just because I built an application, but because I got to work on a real open source project with the real user and the real hardware. So if we talk about the challenges, so one of the biggest challenges I faced was the colored KML issue. Everything was working fine on my local rig, but when I sent my API for testing on the Liquid Galaxy Spain rig, the actual physical rig where the testing is done, my visualization was not appearing correctly. So at first it was very difficult because I couldn't directly see what was happening inside the remote rig. I had to stop guessing, and then I just I had to start debugging the system step by step. So I started the existing Liquid Galaxy code. I looked through the different repositories, and I eventually built a self-diagnostic into my application to find the exact problem was. So that experience taught me an important lesson. When working with a distributed system, you need to have a good debugging and good visibility into the system, especially when you cannot directly access the environment. In my case, I cannot directly access the spin rig, but I had to build a debugging system where I can debug the ongoing issue in the testing environment. And I also learned a lot about the open source development itself. I learned how to work with maintainers, other contributors, review comments, improve my code base based on the mentors feedback.
West Bengal is India's largest rice producing state with over 15 million tons annually. The fertile Gangetic plains and abundant rainfall make it ideal for paddy cultivation. Rice follows a seasonal cycle driven by the monsoon. Sowing June, July. Seeds are sown in nursery beds with the onset of monsoon rains. Transplanting July, August. Seedlings are transplanted from nurseries to flooded paddy fields. Growth August, September. Rice plants grow and develop grain heads with continuous water supply. Rice follows a seasonal cycle driven by the monsoon. Sowing November, December. Winter rice is sown in irrigated fields after Kharif harvest. Transplanting December, January. Seedlings are moved to main fields in cooler winter conditions. Orissa receives 1,489 millimeters of annual rainfall. 34.7% of rice area is irrigated. Mid India's rice production depends heavily on water. States like Punjab rely almost entirely on irrigation while others like Assam and Orissa depend on monsoon rainfall. Punjab has the highest irrigation coverage in India at nearly 99%. With only 649 millimeters of annual rainfall, the state depends almost entirely on tube wells and canals to sustain its massive rice production.
¿Lo vas a presentar todo? No.
Some receives
Tienes que dar.
Hey guys, it's Vedant, a senior mentor at Liquid Galaxy, and this year for GSOC 2026, I was the mentor of Vinayak Thaka, whose project was about visualization of rice farming agriculture on Liquid Galaxy on Google Earth. So the focus was on visualizing rice production statistics and data on Liquid Galaxy, irrigation metrics, then rainfall metrics, visualizing all of this data which was related to agriculture and rice farming in India specifically. And I think Vinayak executed it beautifully. Vinayak has been a really good contributor, meaning in like for the first 2 weeks, it was a little difficult with him because he was a little nervous and he was fearing failure a lot and he was just very paranoid about it. So for the first 2 weeks went into removing and getting rid of his fear. but after that he was quite good. And you know and he was very communicative as well. He would simply reach out to me. We connected a lot. Even in urgent cases we had a lot of phone calls, so if he faced any big issue he would just call me. And I think that was the best thing. And most of the things he would sort himself, and I would only give him direction. And I think that's how it should be. The contributor should be responsible for solving their own problems, and the mentor should guide, not actually solve their problem for them. And I think Vinayak has been the textbook contributor in that case. And yeah, I think the experience overall has been really good. He has good communication. That's something which I would say, because he kept all of us, me and the secondary mentor Dave, updated with all of the information. So I think that was a really good thing from his side, and kudos to that. Apart from that, the project itself is good, and you yourself have already seen the project, I believe, if you're watching this video. So yeah, that's it. I think Vinayak has done great work, and I hope he keeps doing that. All the best to him, and I hope he stays with Liquid Galaxy more. Thank you.
Hello everyone, my name is Darpan Baviskar and I am from Dhule, Maharashtra, India. And currently I am studying at IIT Jodhpur. For Google Summer of Code 2026, I had the incredible opportunity to work with the Liquid Galaxy organization, and my project is the LG Interactive Onboarding Guided Tutorial and Learning System. And the goal of this project was to dramatically lower the barrier to entry for the new users and developers which are interacting with the Liquid Galaxy Regs. I built a comprehensive Flutter application that gamifies the learning process, provides a no-code 3D model builder, feature a fully integrated SSH dashboard, and even includes an AI mentor to assist users in real time. And today I'm excited to walk you through the architecture, the code, and the live demonstration of what I have built. So let's dive deep into the code. So the application is built using Flutter and the Dart language, and at the core of the UI I have designed an actual navigation system using an indexed stack. So this is crucial because it ensures that our heavy screens like the 3D map and dashboard maintain their state when the user switches tabs, avoiding costly rebuilds. And for the state management part, I have fully migrated to the river pod. uh, Using that package, using the notifier provider and the listener builder allowed us to create a highly reactive and a decoupled architecture. For example, when a user sends a command to the LGRig, the state updates instantly across the UI without blocking the main thread of the application or the mobile. On one of the biggest features of the 3D model builder was that users can import raw collada, that is the DAE models and zip files. And to render this on the Google Earth, I had to ensure the geometry was perfectly formatted. I wrote a backend Python script that runs on the Liquid Galaxy itself. It handles the DA triangulation, parsing complex tri strips and dry fans, and auto injects the fallback materials. And a major roadblock we hit was the out of memory crashes on mobile when passing massive 3D models. And to solve this, I ripped out heavy XML DOM parsers and replaced them with lightweight regression expression streams. This drastically reduced the memory footprint making the app capable of handling massive architectural files seamlessly. And to assist users, I built an AI mentor. This isn't a standard LLM wrapper. Instead, it is I have implemented a local vector retrieval augmented generation system. Initially, loading thousands of vector embeddings was locking up the UI thread and crashing the Android devices for testing. So my solution here was to offload that JSON, passing entirely to background isolates using the DAT compute and root isolate tokens. Furthermore, I migrated the passed data into float 32 list, which halved our peak memory spikes. This is then the it is coupled with a open router integration for dynamic AI responses, fully accessible with voice using the Flutter TTS. Also, interacting with the Liquid Galaxy screens require generating precise KMLs, and I engineered a custom orbit generator that dynamically constructs a native tour KML smooth tags, and this allows us to create a smooth cinematic orbital flyovers around the 3D model on the physical screens. Uh, I have also built a system KML slot architecture for Playground, which allows us to dynamically inject customized educational balloons and testing shapes without disrupting the master KML state. And finally, the dashboard. Using Dart SSH2, the app establishes a secure connection to the Liquid Galaxy master node, but the hardware control is risky. So I engineered a strict fail-safe execution and timeouts to prevent deadlocks. I also resolved complex race conditions that were causing the UI state desynchronization when the user rapidly triggers power commands like the reboot, clear, or relaunch. And every critical action was wrapped in a confirmation flow to guarantee system stability. So now I will be explaining you the code base of my Flutter project. So as you can see here, uh, in the lib folder and the source folder, there are two main folders, which is the common and the feature folder. And in this common folder contains most of the SSH connection business logics, and a constant folder which contains a file name appconstant.dat. And the main crux of this file is that all the global variables and parameters are situated in this particular file, which makes it more maintainable and modular. Also in the common directory in the SSH, I have developed and tried to remove all the unrepresentable states in the SSH connection, like the desynchronization between the actual SSH connection and the one which is showing on the UI of the app, using the using the sealed classes in the Dart language. And um, and in the features folder and the source directory of of this project, there contains all the features present in the app, uh, and these are all the features which the user sees on the app, and every feature has its own folder which contains their business logic and any other connection with the common folder, which requires the SSH connection files to be imported, and it also contains their own UI logic as well. So there are many features here: the About AI Mentor, Architecture Explorer, the Curriculum Engine, 3D Model Builder, etc. So this was all about this thing. And furthermore, in the Assets folder, you would see all the KML icons like this. These are all the KML icons which will be seen on the KML balloon when a particular KML will be pushed via this app on the Liquid Galaxy rig. And apart from this, there is a vector embedding in a JSON zip format, which would be used by the AI mentor to give niche answers to your questions regarding the Liquid Galaxy and its architecture. Also, in there are also the logo folder, which contains the logo and the logo banner for the project. And there are also some pre-bundled models which are required for the 3D model builder, where the user can use them. And this is the most important part of the 3D model builder, which is the triangulation script, uh, which is made in Python. So this script has all the logic to convert any generic model and triangulate it, like convert all the polylist tags into triangle tags, and just remove or replace any incompatible tags with respect to the legacy Google Earth engine on the physical Liquid Galaxy rig, to make it compatible and successfully render it onto the Liquid Galaxy rig. It contains some functions which uh, converts the polylist into triangle tags. Then there are some mathematical functions which are used to scale the size of the model instead of using the KML tag as in the KML wrapper. It directly increases or magnifies the size of the model directly via changes in the model file. And it also includes some functions like strip transparency, then strip any useless libraries, and also normalize the shaders if there are any complex shaders which may cause the 3D model to render in an unexpected manner. And there are a lot of functions in this triangulation script. So this was all about explaining the code for my Flutter project. So I will be giving you a quick demo of my app. So this is the app, and it has a 3D model builder option. Let's say I'll select an option of the car, which is a pre-bundled model, and select any location and map, and use the sliders to increase the size and push it. It will take some time to have a successful push, and after doing it, it will make a fly to that location. And as you can see here, the 3D model is rendered and the KML balloon is also there. And I have created an optional option for the user to use the orbit, which does a 360-degree revolution around the model. And I have also a robust clearing mechanism which removes the model not only from the apps from the Liquid Galaxy Google Earth engine, but removes it from the master nodes file directory completely, which avoids the junk aggregation over the long use of this app. Also, there is this KML playground section which contains many entities where one can just use this polygon and push it onto the Liquid Galaxy rig. And as you can see, the KML balloon is appeared here, and soon a flight tour will take place and the polygon will be appeared. And as you can see, the polygon is appeared here. And apart from this, there is this curriculum engine section and this AI mentor section for asking niche questions about Liquid Galaxy. Working on this project for GSOC had been an incredible transformation experience for me. The most challenging part of the summer was definitely dealing with the hardware limitations, specifically overcoming the out of memory crashes and deadlocks. It pushed me to deeply understand the Dart isolates and concurrency and the memory management, taking my engineering skills far beyond the standard UI development, and figuring out how the triangulation of the legacy DA files via Python works on the remote machine. It was tough to understand, but incredibly rewarding when the models finally rendered perfectly across all the screens. And I want to give a massive thank you to all my mentors, Andrew sir, Oscar, and Dennis. Their guidance, their code reviews, and patience were totally invaluable. They fostered an amazing open source culture and that encouraged me to experiment and solve complex problems independently. Uh, and to the open source community and the Google Summer of Code program, I thank you for this platform, and I'm extremely proud of what I have built, and I'm looking forward to continue my contributions to Liquid Galaxy in the future. Thank you for watching.
Settings tab and fill in your Liquid Galaxy host address, port, username, and password. Tap the Save. Tap Import Model, or choose a bundled sample model to get started. Accepted formats: .day, .obj, .glb, gltf, .kmz. Read through the less than model greater than block. Notice the less than location greater than, less than orientation greater than, and less than scale greater than elements. These map directly to the sliders you configured. Open the KML Playground from the main menu or dashboard. Write some custom KML or use the default and tap Push KML to send it to the rig. Navigate to the AI Mentor screen. Type a question in the chat and send it to the mentor. Open the Architecture Explorer. You can find it in the Learn tab or by tapping the eye icon in any screen's app bar. Tap on at least one highlighted component in a diagram to see a detailed explanation. On the dashboard, scroll down to the Maintenance section and locate the Deep Clean card. Tap Deep.
¿Ya está, Jan? Ah, pero estás con la demo ahí.
Hello everyone, I'm Oscar. I'm one of the mentors for the Liquid Galaxy project, and this is my third year mentoring a contributor as part of the Google Summer of Code program. This year, the contributor I've been mentoring has been Darpan Baviskar. As a mentor, I believe that every year I've learned something new, and to be honest, this year has taught me plenty of things. I think that AI has had a huge impact, especially during this year, in the Liquid Galaxy, but not just Liquid Galaxy, but also as part of Google Summer of Code in general, the way we interact with contributors, what they expect from us, the things we can actually provide them as support and help, because traditionally it's been helping with coding or approaching things, but it's been changing. It's been changing because this year it has felt more like, are you sure you're doing what you are expected to do? The thing about generating your code is that you have to not just understand it, but also place the sufficient time with it in order to understand if it actually, the features you want to get in there are what's aligned with your timeline, with your proposal, and what Google would expect from your program. And I think in this case, since contributors in general, and therefore everyone else, are not spending as much time with the code, it's easier to just drift towards the main paths that would get you to deliver what's intended to deliver. And that's what I feel has been the most different thing this year. Luckily, I think Darpan has been able to get to the milestones he proposed. It hasn't been like an easy path towards that goal. And if Darpan, if you're watching this, you know that it's taken some time to get things properly aligned. But I believe that eventually you have gotten there, and I want to congratulate you for that. There's a lot of people that want to get into GSOC, and a lot of people who get in there that don't really get to finish the things they want to do. I think you're not in that group of people. I think you got to where you wanted to get to, so that's great. Now, that's mostly it. I don't know how things will look in next year. I'm quite intrigued to see what is expected from us in the coming years, if GSOC is still a thing by then. And to everyone, to all contributors that have completed GSOC this year, congratulations. Remember that GSOC doesn't have to finish here. We'll be doing this year after year as long as we can, and you can be here with us doing this as a mentor, maybe even as a contributor one more year. I think that's a possibility as well. But this doesn't have to be a goodbye if you don't want to. So thank you, everyone. Thanks especially to everyone involved in the Liquid Galaxy community, and my co-mentor, Denise, as well. Thank you so much for being there with me. And also thank you so much to you as well, Darpan, for getting yourself to complete this project.
Hello community, I'm Denis, and this year I co-mentored the project Liquid Galaxy Interactive Onboarding with Oscar Carrasco, and the project was developed by our collaborator Darpan Baviskar. The project simply aims to teach Liquid Galaxy in a way that people can interact with it, and it embraces the philosophy of learning by doing. It had some features including KML Playground and 3D Model Builder, and live lessons as well, dictated by AI voices. So I would say this was a very interesting experience for me, and even though I don't have any other GSOC experiences in the past, I can definitely say that this Google Summer of Code was something special. And the reason is because of the wide usage and commercialization of large language models. Why? I'm working in a car rental company, one of the biggest car rental companies in the world, and I see this behavior in software engineering, that even some senior engineers might have the tendency to surrender their brains to AI, which means they generate some code, they feed the ticket description and requirements, and then just don't question what LLMs are doing. And I don't like this pattern. In fact, I hate it, because then we are generating so many lines of code, but we don't know what it's doing. In this regard, Oscar and I always try to guide Darpan in a way that he develops his features step by step, but most importantly, understanding what the code is doing. And he was also successful with it, because when we asked questions left and right in the code reviews, in the pull requests, he was able to answer, and he was able to demonstrate his knowledge to us of what he has been building. So congratulations to Darpan, and he took most of our feedbacks. Some feedbacks were he let's say he might have preferred to go another way, and I'm really proud of him because he also chose his own way of like working. But what I tried to guide was building features in parallel and then having separate branches to not propagate any bugs further. In the final phases of the project, Darpan had a bug that Oscar and I were able to reproduce in our own Linux systems because it wasn't so easy. I mean, it was very difficult for Darpan to reproduce it. However, after we managed to reproduce it and sent him our feedback, he was very quick to fix it. So this year has really been special to me, and I congratulate Darpan and all other collaborators. I hope you enjoyed Google Summer of Code. I certainly did. Yeah, my final message would be to keep questioning and don't surrender yourselves and your brains and your creativity to artificial intelligence. Bye.
Hello everyone, my name is Harsh Mehta. I live in Pune, India, and my university is Vishwakarma Institute of Technology, which is also in Pune itself. The name of my project is Local AI with Gemma by Google. So it is an agentic AI project for Liquid Galaxy.
So unlike many other projects, my project does not involve a lot of coding. It's more about using Hermes agent to develop skills. So let's first begin with understanding what Hermes agent is. It's an agent framework from Nose Research, and instead of us building an entire agent system from scratch, which includes to have a agent loop, tools, skills, memories, different profiles, gateways, sessions, and schedule tasks. Instead of us creating all this from ground zero, we use Hermes, which provides us these things. And if you would like to understand all the terminologies in depth, I have also done another presentation on 14th of August. So make sure that you check that out because I have explained everything in depth. It is a very long presentation, more than 1 hour, and I have also explained all the skills that we had developed in detail. So this is some examples of what Hermes agent user interface would be like. You can use it through web or CLI. This is the architecture of Hermes agent. So first you have the main agent loop. So these are some terminologies that we had in previous first slide. So I hope that you will get a gist of it. The main loop is to understand the user prompt. After that, plan to decide what we need to do and what actions to take. After that, you will take actions. Now this is done with the help of tools, which are, for example, SSH file system, HTTP request, KML render, or database, which means the agent does all these tasks, and in order to do this, it has tools. Tools are also an extension of your prompts, which is consisting of user request, the user input, then the skill markdown. I'll also show you the format of skill markdown in coming slides. After that, your tool definitions and what kind of tools you will be using. All things are compiled by the agent itself to give you an output, or to take the action is a better way to describe it. So the actions are performed. After that, it will observe the output or the result, and then these things will keep on repeating in a loop until the task is completed or not. So, for example, if you would like to visualize a complicated KML. Let's say the air traffic over India as an example. First, it needs to fetch all the information about the flight data. So it will first understand my request. It will plan what it needs to do to complete this task. It will act. So let's assume it will perform a web search and then get all the information. After that, it has to create the KML. After that, it needs to use the scripts or tools to perform SSH and connect to LG1, and then it has to push the KML onto the rig to visualize. So it is not that it will just happen in 1 second. It takes a few minutes, but not very long. Mostly 1 or 2 minutes is fine, and it will visualize things for you, or it will continue to work until it has achieved its goal. So skills that I talked about, I'll describe them in detail in the coming slides. There are some other background services as well, which Hermes supports: cron jobs, triggers, gateway, logging and monitoring. Logging and monitoring is just keep maintaining a record of your metrics. Then gateway helps us to connect you to Telegram, Discord, WhatsApp, Slack, web API, anything. So you just enter your message there and it will communicate with your agent wherever it's running. So gateway manages all that. Scheduled triggers are just and cron jobs both are just a task that you have planned for the future. So it will be keeping a record of that, and when the time occurs, it will perform the task automatically on behalf of yourself. There are external systems. In our case, also we have used several APIs, open APIs, to get information for many skills. So you will see that in the coming slides as well. You have features like context compression and context construction. So context construction, as I said earlier, your user prompt, then the skills, your memory, persistent memory, your session history, external data, all such things are added along with the LLM's not along with, but to the LLM's inference to be precise. And all these things together form a prompt. After that, context compression is another feature wherein if the particular memory is exceeding certain character size or is about to reach that limit, it will just summarize it and maintain a compact version, maintaining only the information which is most important, or keeping the main points and removing the bloat. Now, what makes Hermes interesting? As I said, I'll talk about skills more. So this is that section. So skills are reusable instructions for doing specific jobs. It's at a very high level just a markdown file which gets added into the prompt, but it mainly has instructions for doing some various things like LGSSS control is the first skill that we had developed. It knows how to, it has instructions, it does not know, but it has instructions to connect. How do we connect to Liquid Galaxy, then verify those things. How do you relaunch your rig? How do you reboot, clear KML, and other basic tasks like where do you add the balloon and what should be the format of that. So all these things are a part of this particular skill. Now skills use something called tools. Tools are the entities which can take that action, and skills are the ones which will tell you how you can do that. So the actual tools will be shell commands or Python scripts. There are a lot of Python scripts that Hermes uses. It creates it on its own. You don't even have to be aware that something uh, that sort exists. You just have to give your natural language prompts and it's just done. So you have APIs, browser operations, etc. There are also multiple built-in tools that come with Hermes. So that is why we use that instead of creating our own agentic AI system. We are just extending it for Liquid Galaxy. That's the main idea. So after that, a memory stores useful information beyond the prompt because every LLM has a specific context window. It shifts. So the things which are left out are forgotten by the LLM. We don't want that to happen. So we store it, all the important things in persistent memories. Even your skills get modified as per your request. So more you use it, the better it will become. After that, you have separate profiles. This is also an important section because our profile is we the final delivery to be correct is a Hermes profile. So it has my skills, memories, and all the sessions and the environment details that we have developed with the help of Mentor Andrew and Mentor Moises and myself to use that for Liquid Galaxy. So even if you have your Hermes agent already present, you don't have to remove your data. You just switch the profiles like you have profiles in your laptops. You, if somebody else is using, you just log in with their credentials. So in the same way, you will just import this profile and you can use this project for yourself. After that, uh, about Nara, I'll just describe this in short. So Nara is the name of the project which we have created, and it's built using Hermes agent. It's a customized profile basically, which has different skills for Liquid Galaxy. And coming to the skills, instead of making a giant prompt like me having to type again and again on how it has to do things like SSH control or creating KMLs, it will just read those skills again and again. So I teach it once and it will keep on reusing it. That's the main idea of skills. So this is just an example. It will the LLM or the agent will identify what skills it needs to use. It will be aware of the skills it has and it will just use those. This is the standard skill directory, and this is the standard skill architecture. You don't have to learn it, or you don't even have to understand it. All a user has to do is type in their requirement. The agent will handle everything for you, but just for knowledge, this is the format of every skill. So this is shared with the LLM when required. Description, version, author, metadata, all all the information is here. Reference, procedure, pitfall, verification. So it's pretty robust. And about backup, so a backup is like the word says, it's a backup. So the profile that we make, if I need to share it with somebody else, I create a backup. There can be multiple types of backup. One is full backup, which contains all my profile. One is profile backup, which is a better way. So you can just, I can export first the Liquid Galaxy profile and you can just import it on your end and it will just work the same.
Now let us try the natural disaster skill. Can you show me a natural disaster that is happening in Spain, the recent wildfires on the Liquid Galaxy? So now let's try the geography educator skill. It will teach any user geographical concepts by showing it on Liquid Galaxy. And show me how. This is a example question that I have given on understanding how river deltas are formed. So let's see the output. Okay, so this is the output. It is given as an example of the biggest delta of the world, which is in this region, and you can also read the text on the right hand side. So my personal experience has been really amazing. I learned the problems that people face with AI agents on a daily basis, and then how we can tackle those problems, such as issues with memory or making the agent follow the instructions always, making it compatible for different devices. I also learned the importance of a very good research and also being up to date with the new features and developments that occur, because times are crazy and every 2 weeks there is something new that comes up. So I'm also thankful to my mentors, Mentor Andrew and Mentor Moises, because they have helped me in so many ways. Like Mentor Andrew used to send me anything that he finds new with my Hermes agent. He shares the features with me and I can just refer it, and if it's something very good, I add it to my project, because my project was not a fixed defined project from the start. It's evolving and it will continue to evolve in the future as well. So also mentor Moises had taught me many things about AI agents and how we can create an architecture which will always be a standard to create new skills if a new user creates them at runtime, and the importance of having a very good and very clean documentation, since my project could be used in the future also, and it could have audience which has technical experience or which does not have technical experience as well. So it makes a person to use Liquid Galaxy very easily without writing any single line of code. The agent will do everything. So the documentation also needs to be in a way that it can be understood by everyone. It should be to the point, and they always guided me on what things I should have and what things I should remove. And in terms of technical expertise, they have a lot of knowledge and experience. So it was really amazing to being able to learn from such people. So thank you so much. Okay, so now let us try the history educator skill. Can you tell me or teach me the history of the movie Odyssey, the concepts and the past that it is based upon? This is a bit of complex because first it will have to search for the movie and then understand the context, then understand the history, and then create KMS and show it on Liquid Galaxy. Okay, so this is, I think, the entire map of the events that had happened. You can also read it here. So this was where the final battle must have taken place. So now let us try to see the air traffic over some other region like Canada. Can you show me air traffic over Canada? Okay, so these are all the flights near the Canadian region. It is not 100% accurate, but it's almost accurate. You can see different flight IDs and their height from the ground. All these space marks represent a flight. So that is a lot of traffic. So this is just another example of the flight visualization, where instead of pin marks you can see actual aeroplane symbols. Now let us try the global deforestation skill. So clear cameras and show me deforestation in Amazon in last 20 years. Okay, so the KML is ready finally, and we can view the deforestation activity that has happened in the Amazon rainforest. This is area wise comparison that you are looking at. In every year, how much deforestation had happened.
infinite power, infinite power, infinite power, power, infinite power, infinite power, infinite power.
Infinite power.
Hello, my name is Moises Martinez, and I have been a GSOC mentor at the Liquid Galaxy project for the past 5 years. This year, I have the opportunity to mentor Harsh Mehta on his project Agentic AI with Liquid Galaxy, in which he built an agent-based system that enabled users to control Liquid Galaxy via commands to visualize different type of informations on the screen related with the command that he sent. Developing this project presented several challenges because it had to be scalable, modular, and clearly documented so other developers and users could pick up where he left on. Despite these difficulties, Harsh has done a good job and successfully crossed the finish line of the GSOC after all these weeks.
Every year, GSOC is different. This year we are having what we call the tsunami, the AI tsunami. And there are some projects that use the technology in a, I would say, slightly way. But we, as we always try at the Liquid Galaxy project community to continue on the wave, on the top of the wave of the technology, this year we have tried to implement brand new technologies related to AI to our project. And one of these projects is the one made by contributor Harsh. Contributor Harsh started early, I would say, January, working with us, collaborating and doing the preliminary tasks in a good way. And then when we were defining his project, it was a little bit difficult, but because this technology is in a totally incredible fast pace, and I would say every week there are news, and it's totally crazy. So we started to ideate the implementation of this new brand in these times, November, December past year, January this year, 2026, the agentic think for artificial intelligence. Then there was the system was around the lovely lobster, the open cloud, but I would say open cloud lost a little bit of their force, and we finally decided to go for Hermes. And contributor Harsh was, I would say, a little bit lost when he finally was selected for GSOC with the great and always helpful hands of mentor Moises Martinez, Google developer expert in machine learning and artificial intelligence. So we started the project, and we all were a little bit lost because when you are creating technology and new things, just riding the same wave of very fast-paced development is difficult. It was a little bit hard to cross midterm, but we finally achieved. And I will say that after midterm, the project improves a lot. I will say I push more for the implementation of technology and mentor Moises, that is also a teacher or a university for very high-level students with very, very good profiles. He pushes a lot on the documentation and the way of doing the things. And I think that the three we achieved to a very good point. So, project from Harsh, I think will be very useful for the community. It's a very important change on the way we do the things at the Liquid Galaxy, and we don't know what's going to happen in the future, but we have it here. And also we are creating, and you all have to know the information already, a new contest this September regarding implementing new skills for this agentic AI project that contributor Harsh, with the help of mentor Moises and me, have implemented. So thank you, Harsh. It's been a long journey. You performed well, you did it well, and I hope your project is one of the new legs for the future of the Liquid Galaxy. Thank you.
Hello everyone, I'm Soumya Bhattacharya. I'm from Kolkata, India, and today I will be presenting my application UNESCO World Heritage. which I have built as a part of GSOC 2026 for Liquid Galaxy organization. Let me walk you through the key functions of the UNESCO World Heritage application. First, starting with the LG-RIG service.dart, we talk about the connect function because the first thing the app needs to do is to establish a connection to the Liquid Galaxy cluster. The connect functions open an SSH socket to the LG rig using the Dart SSH2 package. It takes the LG connection settings object, host, port, username, and password, and sets up an SSH client. If anything goes wrong during the handshake, it cleans up and rethrows the error. Alongside, we'll be talking about the disconnect function, which closes the SSH channel and nullifies all the state. Notice that the connect calls the disconnect first, so reconnecting is always clean and all other LG operations become available. Once connected, the application communicates with the LG by pushing the KML files over SFTP. The send KML function writes content to the master.kml, the central display file that the main screen of the Liquid Galaxy reads. The send KML to slave function targets a specific slave screen by their index. For a multi-screen rig, the app has to have a smart helpers such as the send KML to the leftmost screen and the send KML to the rightmost screen. For a multi-screen setup, the app has to have smart helpers such as the send KML to the leftmost screen that targets the far left display, while the send KML to the rightmost screen targets the right side for the information balloons. The clear KML function resets the entire rig by sending a blank KML to every screen and stopping any active tour. Now let's talk about the KML builder.dart. The most important and complex function of this class would be the build boundary KML. This takes up polygon ring coordinates from the UNESCO geometry API and converts them into 3D extruded KML boundary that Google Earth on the LG rig can render as the walls rising from the ground. It has two modes, which is supported by the Simplify for LG, which is true by default. So it rounds off the coordinates to three decimal places and caps rendered polygon components at 30. The next class that we'll be talking about is the KML builders.dart. Now, the most important and the complex function for this class would be the build boundary KML. It takes polygon ring coordinates from the UNESCO API and converts them into 3D extruded KMLs that is rendered on Google Earth for running on the Liquid Galaxy rig and can render them as 3D hollow balls around the site for their respective coordinates. It has two modes, which is controlled by Simplify for LG, which, when true, rounds coordinates to third decimal place and caps the rendered polygon components at 30. This keeps the SSH transferred KML small and GPU friendly. The colors are category based for each of the KML that is rendered for the UNESCO sites, which is as followed that the cultural sites get a golden yellow color, the natural sites get a neon green color, and the mixed sites get a cyan color. The extrusion height is 130 meters for the standard LG rig. Next, moving on to the UNESCO site geometry repository implementation, which falls under the models category, is an important function which is the get site geometry. Now, for the logic behind this function is that it implements a four-tier fallback chain to handle every possible data availability scenario. The first is check in the memory cache if we have fetched this site before and return it instantly. The second is try the official ArcGIS REST APIs for UNESCO's own boundaries and buffer layers. The third is for natural and mixed sites where we try for the WDPA API endpoints, which is the World Database on Protected Areas, which uses fuzzy string matching via the string similarity package to find the best candidate name. The tier 4 If all of these fails, we use the Gemini API key, which is already configured, and call the Gemini AI to generate an appropriate polygon with all the approximate values from the official UNESCO API and the boundaries and the area that it covers to create a proper coordinate for a particular site. And if nothing works, a circular fallback ellipse is generated mathematically from the site's GPS point. Next, moving on to the Gemini AI. The app has a built in AI travel guide powered by the Gemini 2.5 flashlight model. The init chat functions creates a persistent chat session with a system instruction that primes Gemini to have a behavior of a knowledgeable local travel guide which is concise, accurate and helpful. The send message function sends the user queries to the chat session and strips any markdown formatting from the plain text to UI. Separately, the get places uses a structured prompt to ask Gemini to return a JSON array of nearby places of interest, each with name, latitude, longitude, a short description, and an image URL. This powers the nearby attraction features inside the app. One of the most important features and the required features for this application is the synchronization between the map on the mobile screen and the Google Earth shown on the Liquid Galaxy rig. The on camera change function fires on every map camera event. To avoid flooding the LG's SSH channel, it uses a 300 millisecond debounce timer. Only the final camera position after the user finishes moving gets sent. The zoom to range helper converts Google Maps zoom level to the Google Earth KML range values using the formula which is the range is equals to 35200 by 2 to the power zoom. The resulting fly to view command is piped over SSH. For the site imagery, for the sites having the array for the image URLs as null from the official UNESCO API, it uses the Wikipedia REST API to fetch the image URL, which searches the Wikipedia for the site name and iterates results to find one with a thumbnail and prefers the exact title match. The URL is then upgraded. It replaces the small thumbnail with 960 pixels to get a high quality image. Both image and description fetches are backed by an in memory cache and a concurrency limiter using a completer queue, preventing the Wikipedia API from being overwhelmed when many sites load at once. Another important part of the application is the AI voices that are used to answer the queries of the users or to narrate the stories. As you can see, that my application here is already connected. It has all the credentials present here. It has an LG command screen which has all the list of LG commands that the user can use by using the buttons present here. Next, we have the API authentication page with my Gemini API key. The user can put in their own API keys and use it in the application. Next, let us go to discover some sites. Let us say we go to this site. Now, as you see here that we have the 2D KML for this particular site on the phone and the 3D KML with its 3D boundaries on the Liquid Galaxy screens. It has a few metadata like from where it is, what kind of site it is it in danger or not, its inscription here. It has an explore card where the user can hear the AI generated stories and fun facts about this particular site powered by Gemini API. Next, it has an Ask Gemini page where we use the Gemini Glide for answering user queries. The user can ask questions in text or in speech. For now, I will be using in text. So if I asked when was this site inscribed and I ask a question to Gemini, it gives the answer seamlessly. Now, next, I have the climate tab where we have the temperature, the wind speed, the best time to visit this particular site. And all these data are also present in the rightmost KML balloon with all these metadata and a bit of explanation or description about this particular site. Now, if I click on to orbit, an orbit starts around this particular site as you can see that we have in proper orbit. The user has the option to stop the orbit as well. Now all these sites are color coded since this site is a natural site, so it is green in color. If I go on to some other site, let's say this one, since this site is a cultural site, it is golden yellow in color. Here it is. And it also has the same format as the other sites. It is consistent. The user can play the story, can mute and also replay the story again. Next up, we have the filter screen where the user can apply filters where it is having data like the year inscribed, which can be a range or a single value, the region, the state name, the category, and also show sites which are in danger or not, and they can apply the filters and view the sites. We have a carousel for the state names where the states are collated with respect to the site's state name. Next, we have the home screen which shows the sites near you. We also have the about page with the help section regarding all the FAQs that a user could have with respect to a site. So my GSOC experience has been really amazing. I have learned a lot about AI, about routing, about KMLs, and also about visualization. It has been a wonderful learning experience, and I really look forward to be connected with the community. The community has been very helpful, and I'm really grateful to have this opportunity to be a part of GSOC 2026 and learn so much from the community, from my mentors, from the admins, and everyone in this whole journey. Thank you so much. And also, really thanks to all my contributors who have been a part of this journey with me for being supportive, helpful, and also really cooperating. Thank you so much, everyone.
Nestled in the heart of Catalonia, Spain, Poblet Monastery is a UNESCO World Heritage. Nestled in the heart of Catalonia, Spain. Nestled in the heart of Catalonia, Spain, Poblet.
So I said, no, 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 it was supposed to be my pentakill. Why did you die to me? I killed alone, want to free for champions. I can't believe it's falling. No, it was supposed to be my pentakill. Why did you die to me? I killed alone, want to free for champions. I can't believe it's falling.
So, hello everyone. I am Rohit, one of the mentors at Liquid Galaxy under Google Summer of Code. And this year I had the opportunity to mentor Soumya, and it had been really a good experience and seeing her journey throughout the program. So, from the very beginning, she was very curious, consistent, willing to understand, and not just what needed to be built, but also why we are doing it, uh, going through the designs and going through the architecture, going through the process, the thoughts, etc. Soumya adapted well to the open source environment. Now, whenever she faced challenges, I seen her going through difficult situations where the camel was not loading onto her screens. So that panicked her a bit, but we then debugged it thoroughly, and finally we were to came to a solution which really helped to show the camels onto the screens. And she was like willing to explore, ask the questions, then she was taking the feedback and improve the approach. And she didn't ask it directly, but she first tries it out, then if it didn't work, then uh, she asked for the help. So over this time I could see her becoming more comfortable with the project and taking the more ownership of her work. So for me, one of the best parts of being a mentor is watching that growth, when she was just applied and working on the projects, and finally now she's ending a Google Summer of Code. So it is not about completing a project or getting the code merged, but it is also about learning how to work in an open source community. And you get to know many things from your peers, from your contributors, from other mentors, and this is the whole process of learning. So, and one of the most important things is the communication. So she was really good at communicating her ideas and the problems, etc. So I think Soumya has grown in all of these areas and during her GSOC journey. She has been sincere about her contributions and has shown a genuine willingness to learn and to improve the throughout the program. I'm really happy that I got the opportunity to mentor her, and I hope this experience become the beginning of her much longer journey for her in the open source. Now, I would definitely encourage her to stay connected with the Liquid Galaxy community and continue contributing, and hopefully in the future help and mentor other new contributors as well. So, thank you so much.
Hi there, I'm Yash and I'm recording this for Soumya for her World Heritage app that I got to mentor alongside Rohit. And here I also have the app installed. So I was very happy with the application and how the UNESCO World Heritage uses a very nice material UI. Overall, throughout this project, I have seen that there were some very hard deadlines, and how Soumya did very well throughout the time, trying to make sure everything gets done, not just like on time, but way ahead of time whenever possible. She was also stuck at some of these issues where she finally got the nicest UI that I really like, which is using materials way of UI. It is all so much nice with the kind of widgets that she brought in. Everything has a nice color contrast, and I really love the application. And in terms of usage as well, I really love that it also has the embedded Google Maps, allows us to have the key attached so that we can make our own set of and just view the different kind of sites that are available for the UNESCO World Heritage. So yeah, overall really happy with Soumya, and also a very good thanks to my mentor and friend Rohit, who was always there in all the meetings trying to help out and making sure that this project is a success, which it was. So yeah, thank you so much.
Good morning. Before I start, apologize if my English is not perfect. I'm not very fluent in English, so I have prepared a script to help me during the presentation. Thank you for your understanding. My name is Yasmina Ramadan. I'm 20 years old and recently graduated in multi-platform application development from Ilerna, Lleida, Spain. Previously, I completed an intermediate vocational training program in microcomputer systems and networks, also at Ilerna, which provide me with a solid foundation in computer hardware, networking, and embedded systems. Throughout my academic training, I have actively participated in several technology development projects, which have allowed me to put my knowledge into practice and gain experience in different areas of technology and programming. Currently, I collaborate with Liquid Galaxy Labs, and I'm participating in Google Summer of Code, GEO 2026, where I'm developing a project called City Storage Engine. City Storage Engine is an application designed to provide historical and cultural information about different cities, in my case, Lleida. The main objective of the project is to make relevant information about the heritage, history, and historical events of different cities more accessible, using the visualization and interaction capabilities of the Liquid Galaxy. First, I will demonstrate the application and show how it works, and after that, I will explain the code and how the application was developed. Thank you. Okay, now we can explain the project. The POI is the central data place. One object is one place or one historical event. It stores the name, the image, the story, and the Google Earth camera, latitude, longitude, range, heading, and tilt. Those numbers are the look at, fly to, and orbit. Use them on the rig. We have here the latitudes and altitudes, yes, and the range, the little. Then it also has area, start date and end date for the balloon, get name and get descriptions. Return the text in the current language with a fallback if a translation is missing. Matches search is what the category list use when the user types. Every screen and every Liquid Galaxy command works with this class. If you understand POI, you understand what the app sends to the wall. Now we can go to the connection state. We have here the get description and get name here. And match search here and the get error here. Okay, we can go to connection state. LG connection state is the client, okay, is the SSH client. It is a singleton. Connect tools and LG servers all share one session. Connect opens SSH to LG1, the master machines. It creates the folder on the rig, uploads the partners' logos, and shows them on the leftmost screen. Run exclusive quest commands. 1. SSH right at the time, so two screens cannot collect on the rig. Execute runs a remote command. Write remote file sends a KML, preferably with SFTP. Notify solo KML change tells Google Earth to route one screen, master one in the center and slave on the other screens. On the slave screens, there are other screens. This class does not decide what a place looks like. It only talks to the machine. We can go to service, service. LG service is the most important class. This is what actually presents a place on Liquid Galaxy. Present POI is the public method. The launch screen calls it. Requests are quiet. So, if the user taps two places, the first one finishes before the second starts. Present POI once is the people line. 5 step. 1. Hide the previous balloon. 2. If there is a white image, Chromium service shows it on the 3 central screens for a few seconds. 3. Fly to POI. writes the look at to query txt. Google Earth flies to that place. Yes. 4. For buildings, send point highlight circle draws the OSM outline and send center placement puts a colored print. The color print is different in another places. In other places is the different colored. For historical events, those layers are cleared. The story stays in the balloon, not as a fake building. 5. Send balloon. Writes the HTML balloon to the rightmost screen. Name, area, dates, and description in the current language. Other measures start the orbit. We have here start orbit. Start orbit point rotates heading every half second. Stop orbits ended. Clear cameras, relaunch, reboot, and show logos are used from tools. LG series use LG connector state for SSH. It does not build the UI. It only drives the rig. And here we have the página lanza. Launch page is the screen for one place. When it opens, it enters the point with point localization, then calls present point if we are connected. The user can toggle orbit and narration from here. And this is. Thank you for listening, and goodbye.
During the development of City Historic Engine, my experience has been quite positive, as it has allowed me to put my programming knowledge into practice while also learning new things. One of the main difficulties I encountered was organizing all the information clearly and making sure that the application was simple and intuitive for the user. This helped me improve my problem-solving skills and better understand the different stages of application development. Another aspect that I found particularly interesting was using artificial intelligence as a support tool during the development process. Working with these new technologies has allowed me to discover new ways of programming and explore the possibilities they offer to make the development process easier and more efficient. Overall, I consider this project to have been a very useful experience, as I have not only improved my knowledge of Flutter, but I have also learned how to better organize my work, solve problems, and adapt to new tools and technologies. Furthermore, it has helped me understand that artificial intelligence can be a very useful tool to complement the work of a programmer and make the development process faster and more efficient.
Park, Contemporary Age, 2004-2009. The Agri-Food Science and Technology Park of Lida was inaugurated in 2005 and is the result of collaboration between the Lida City Council and the University of Lida, with the aim of boosting the local economy and business competitiveness. Its history is marked by the transformation of a former military complex on the Gardeny Hill, which belonged to the Spanish Army until the late 1990s. The Lida City Council Church of San Urank, Middle Ages, 1150-1400. This church, which served twice as a cathedral, is a Romanesque structure with
Jack it up.
Hi everyone, my name is Claudia, and this year I had the pleasure of being Yasmina's mentor during Google Summer of Code with the Liquid Galaxy community. Yasmina's project is called City Historic Engine. The main idea of the project is to combine technology, history and culture to create a more interactive and immersive way of discovering a city. For this version, the project focuses on data, allowing users to explore points of interest, cathedrals, churches, museums, and historical events. The application was developed using Flutter and Dart and integrated with the Liquid Galaxy. User can select a historical location from the app and send it directly to the Liquid Galaxy, where Google Earth navigates to that place and shows additional information using KMLs. But for me, one of the most important parts of Google Summer of Code is not only seeing the final result, it is seeing everything that happened behind it. Throughout these months, Jasmina encountered many different technical challenges. There were moments when the connection with Liquid Galaxy was not working correctly, when the tools needed to be redesigned or fixed, when the orbit was still pending, or when displaying the balloons and KML information required several attempts. And that is exactly what software development looks like. Sometimes something does not work on the first try. Sometimes you spend several days trying to understand why a feature behaves differently from what you expected, but what matters is what you do next. And Yasmina kept working on those problems. Little by little, she managed the tools, build a database, correct the coordinates, generate the orbit in Liquid Galaxy, implement the balloons, improving the connection experience, place marks, and continue improving the interface, and the overall experience. So, Yasmina, I want to say something directly to you. I hope you're proud when you look back at everything you have done since the beginning of this project, not only because of the final application, but because of all those moments when something was difficult and you decided to keep trying. That ability to investigate, make mistakes, try again, ask questions, and eventually find a solution is one of the most important skills you can develop as a software engineer. A project like Google Summer of Code is not only about learning Flutter, Liquid Galaxy, KMLs, or any particular technology. It is also about learning how to approach a real project, how to organize your work, how to receive feedback, and how to solve problems that not always have an obvious answer. My advice to you is keep that curiosity. Keep building things. Keep experimenting with technologies you don't know yet. And especially, don't be discouraged when something doesn't work immediately. Many of best learning moments happen exactly there. I really hope that his city historic engine is only one of many projects you build in the future. And finally, I also like to thank the entire Liquid Galaxy community of the organization, administrators, mentors, contributors, and everyone who makes Google Summer of Code possible. Open source is much more than code. It is about people sharing knowledge, help each other, experimenting together, and creating opportunities for new developers to grow. It has been a pleasure to accompany Yasmina during this journey and to be part of the Liquid Galaxy community once again. So Yasmina, congratulations on everything you have achieved. Keep learning, keep creating, and keep challenging yourself. And to the whole community, thank you for another amazing Google Summer of Code. See you next time, bye.
Good morning, I'm Josep and I'm 21 years old and I live in Lleida. I'm currently studying multi-platform application development at Ilerna and I have also been involved in the Liquid Galaxy lab for around 5 years where I help other students to test the applications, giving them feedback, and that helped me to win some experience to work with these applications, and let me learn about more about the Liquid Galaxy, and gave me the opportunity to see many different projects and ways of working with the system. And now, as a developer myself, I had the opportunity to create my own project and apply some of the knowledge I won for these past years on my application. Well, my project is called Geosaurio, and it's an interactive application to explore dinosaurs around all the world. So the main objective of my application is to provide an educational and interactive way to explore the dinosaurs and learn more about them, and it can be explored in different geological periods and different locations. Well, my application starts where the user could select the geological period and the content that they want to go, and once they selected the continent, it takes them there and let them select different countries with the number of dinosaurs on each one. On every country, once the user has entered, it shows different markers showing on the Liquid Galaxy the position of every dinosaur. When the user selects the dinosaur, it zooms to the position surrounding the zone where it was discovered and let the user interact a little with the environment, like making them orbit, listen out the story, or saying like a comparison of the size or the fossil or an skeleton. And finally, the application includes the settings for configuring the Liquid Galaxy and the tools for controlling the system. And the idea behind Geosaurio is to combine the education and technology to make the learning about the dinosaurs more visual and interactive. Hello, I'm Josep, and now I will explain the code of my application. Well, so as I said, I will briefly explain the code and the structure of the Geosaurio. So this project is divided into models, screens, services, and widgets. I'm going through each class and explaining its main purpose. So I will start first saying that I have the folder of assets. I have all the audio that I play for the narration, the data where I have the database, and the images where I have the images of dinosaurs, the point marks, the logos, and the logos. And this is something I wanted to use but I couldn't use. So let's start. Well, I will start explaining the models. So starting with the models, I have the dinosaur class. So this class represents a dinosaur and stores all the information I need about it, such as its name, the geological period, the continent, the country, the coordinates, and other information that I display in the application. And I use this dinosaur object through the different screens and services. Now I will go to the screens. So the screens are the ones who manage the main user interface and the navigation of the application. So I will start explaining the about screen. So the about screen is a simple information screen where I show information about Geosaurio and the project, and I give the knowledge to the people that helped me. Now, to the dinosaur title screen is the screen that appears when the user selects a dinosaur. Here I display all the information of the dinosaur and manage the main interactions with the dinosaur. From this screen, the user can start or stop the orbit, play the narration, see the skeleton, and open the dinosaur comparison. It also communicates with LG service when an action needs Liquid Galaxy. So, an action needs of the Liquid Galaxy. Sorry. Well, now the help screen. This class explains how to use my application and gives a short explanation of the main features available to the user. Now on the home screen, so this is the main screen of Geosaurio managing the dinosaur exploration process. So the selection follows a hierarchy. First the geological period, then the continent, then the country, and finally the dinosaur. Depending on each selection, I filter the available options so the user only see the continents, countries, and dinosaurs that are available. These selections are also connected with the Liquid Galaxy, so when the user selects a continent, country, or dinosaur, I can move to the Liquid Galaxy view to the corresponding location. And finally, when a dinosaur is selected, I open the dinosaur detail screen. Now, on the settings screen, the LG settings screen is used to configure the Liquid Galaxy connection, where the user can enter the IP address, port, username, password, and number of screens, and the settings are used by LG service. Now on the LG tools screen, this contains the main system controls for Liquid Galaxy. From here, the user can perform actions such as cleaning ML, content, or cleaning ML content, managing the logos, like showing or hiding, relaunching the Liquid Galaxy, rebooting the Liquid Galaxy, or shutting down the Liquid Galaxy. Now the splash screen is simply the initial screen that appears when the application starts before opening the main screen, and I also, before it goes to the main screen, I reproduce an audio. Now, The services, when I have the services where this is where most of the application logic is located, and I separate it into different responsibilities. I separate the different responsibilities into different classes. So now the audio service uh, manages the dinosaur narration, so it finds the corresponding audio file using the dinosaur name and manages playing. It manages the play audio, pause audio, or stop the audio. Now the dinosaur service is the responsible for loading and providing the dinosaur data used by the application. So this keeps the dinosaur data separated from the user interface. Now the marker service. So this manages the dinosaur markers in the Liquid Galaxy. It creates the KML used to display the dinosaur locations, manages the 3D KML used of the used to mark the selected dinosaur, what area where it was discovered, and also remove the markers when they are no longer needed. So this is what this class is about, to show the KMLs on the Galaxy and clean them. And when I leave the screen where I show the KMLs, I make them clean automatically, so the user doesn't have to do it. Now, the media service. So this manages the multimedia visualizations, and I use it mainly for the dinosaur skeleton and comparison features. And it also manages Chromium on the Liquid Galaxy screens when it's necessary. Now, the navigation service. So this manages all the camera navigation in Liquid Galaxy, and here I have the movements to dinosaurs, continents, countries, and positions selected from the minimap. For these movements, I create a lookup using values such as latitude, longitude, heading, tilt, and range, and then I send it to Liquid Galaxy through the LG service. And I also have predefined positions for the continents and the conversion between the minimap zoom and the Liquid Galaxy camera range. Now, the orbit service. So I use this service to manage the 360-degree orbit around the selected dinosaur. I use the dinosaur cube position at the center and create different camera positions by changing the heading. The complete rotation is divided into 60 steps, and I send a new camera position every 4000 milliseconds. And this creates the continuous orbit around the dinosaur, and I also have the logic to start and stop it. Now, the overlay service. So this manages the visual content displayed on the Liquid Galaxy screens. This includes the Yosaurio logo and information about dinosaur, countries, or continents. So basically, this class manages the different information overlays. So I will end going down. We also create here the columns that we later display on the right screen. The LG service. So this is the main service for the communication between Yosaurio and Liquid Galaxy. So here I manage the connection configuration, including the IP, port, the IP, the port, the username, the password, and number of screens. And I save these settings using shared preferences. This class also manages the CCH connection and root connection, and I use SFTP when I need to transfer files to Liquid Galaxy. And I also have some shared utilities, for example, they calculate the leftmost or rightmost screen, depending on the number of screens configured. And finally, from this class, I connect the specialized services for navigation, orbit, makers, overlays, media, and the STEM operations, keeping the main connection centralized in LG service. Now, the LG system service. So this service manages the system operations of Liquid Galaxy, and here I have the functions for cleaning and refreshing camera content, relaunching Liquid Galaxy, rebooting, and shutting down the system. As we can see, here we have the reboot, the shutdown, and the relaunch here. And finally, the service manages the light and dark mode of the application, and updates the interface when the user changes the theme. Now I will explain the widget. So the minimap is the interactive map used to display the dinosaur locations. I can make markers using the coordinates of each dinosaur, and the user can select a dinosaur directly from the map. So the important part is that the minimap is synchronized with the Liquid Galaxy. So when the user moves or zooms the map, I send the new position to Liquid Galaxy. I also use a small delay to avoid sending too many movements while the user is moving the map. Now I will explain the drawer menu. So this is the set menu used through the application, and it provides navigation to the different press screens, allows the user to change between light and dark mode, and also shows the current Liquid Galaxy connection status. And finally, the main Dart. So this is the entry point of the application where I initialize your audio and provide the main service that needs to be accessible from the different screens. So from here, Flutter starts the application and opens the initial screen. So that will be everything. Thank you.
Abrosaurus dompoi lived around 160 million years ago during the late Jurassic in present-day China. It was a medium-sized sauropod with a long neck, heavy body, and robust limbs. Abrosaurus was quadrupedal and fed on high vegetation, representing early neosauropod adaptations. Alcovosaurus longispinus was a stegosaur with unusually long shoulder spines and a moderately armored back. Its body was built for slow movement while browsing on ferns and cycads, and the elongated spines may have been used for defense or display.
Talking about personal experience, this project has been quite special for me because I have, as I said, I have been involved with the Liquid Galaxy Lab for years and helping the students with their applications and having the opportunity to develop my own application using all that I learned to help myself to make it was special. And well, during the development of Geosaurio, I faced different challenges, like especially with the communication with the Liquid Galaxy and features like the camera, navigation, and the orbit, where I found some trouble. I also learned more about Flutter, SSH, and KML, and I improved the way I organize my code by separating the different responsibilities into services. Overall, this project allowed me to experience Liquid Galaxy from the developer's perspective and not only from the testing and support side. It has been a very useful experience for me and I'm happy with the final result. And that's everything from my side. Thank you very much for your time and I hope you enjoy Geosaurio.
Hi everyone, hi Andrew, team and the entire Liquid Galaxy community. I'm Victor and once again, it's been a pleasure to be or serve as a mentor this summer for the Liquid Galaxy project. This year, I had the privilege of mentoring Josep on his project Geosaurio. What made this project truly stand out was its unique and creative approach blending history, prehistoric dinosaurs and spatial interactive technology onto the Liquid Galaxy platform. Seeing how history and technology come together in such a visual way has been really exciting. Josep, I want to highlight how impressed I've been with your consistency and dedication right from day one. You faced every technical challenge hands on, keep that steady pace throughout this summer, and turned a great concept into a solid reality. I want to send you my most sincere congratulations on a job well done. You should be really proud of what you have accomplished for Demo Day 2026. Keep pushing boundaries, and I wish you all the best with your Geosaurio and beyond. Cheers everyone, and enjoy Demo Day.
Hello, my name is Jan. I'm 20 years old. I live in Lleida, Spain, and I am currently a contributor for Google Summer of Code in Laboratory STIC. So basically, I have finished my vocational training in a cross-platform development application in Ilerna. So for this year in Google Summer of Code, I have developed an application for Liquid Galaxy, and it is called Liquid Galaxy Time Machine. So basically, Liquid Galaxy Time Machine is an interactive application. It's designed to visualize the evolution of historical landmarks over time. So with the power of Liquid Galaxy, we can basically see the past, the present, and the future eras of these historical landmarks. So we can explore all these landmarks. We can see the architecture and the landscapes of those places, and we can see the transformation that they had over time, over their evolution. And we can see that through immersive 3D KMLs and visualization, and through AI imagery that I have made on the future tab, that is an estimation for the future evolution. Okay. Ya está.
Puedes estar callado.
Ya está, ya está.
Ya, pero que te calles mirando cámara porque si no después yo no puedo cortar bien.
Hello, so now I'm going to explain my code, which I will basically go through each one of my classes that I have here. I have all this hierarchy of my code, and I will go through each one of them in separate summaries. Okay, so we're going to start. So basically, in the database, I have the DB helper. So what is the DB helper? The DB helper, basically what it does is just managing the SQLite of my application. The SQLite is basically just a database locally on your application. So basically, for example, on the language setting that I have for my application, you have English, you have Spanish, you have Catalan. Okay, so when you store this, like when you put it in, it stores on here. It stores locally on your application, on your device. It stores locally thanks to the database. Okay, so that's basically what it is. We're gonna move on with the KMouse. The KMouse is basically just, well, it's just how I have stored all of the XMLs and everything for, you know, for the Liquid Galaxy display. I could have done it separately. I could have done it together on the LG service, but I wanted to, organize it. Okay, so what is the comparison overlay? So the comparison overlay, the function itself is basically just displaying chromiums of the past and the present, or the future and present images, and then a balloon with the comparison of these with a summary. So basically what I have here is just the balloon XML of this. Okay, so you can see on the right side that I have the balloon, and it's basically there. Okay, the chromiums are in the LG service. I will explain later. Okay, so moving on, this is the overlay screen of the logo. So in the left side, when you connect to the application, you can see the logo, and this is basically just the XML for the screen overlay. You can see here that I put the logos in. It's just an image that is being displayed on the screen overlay for the Liquid Galaxy. So the look at camel. The look at camel is basically just putting the look at tag for, when you go to a place, it does apply to, but it needs it needs coordinates, it needs things to know where it's going. So basically what this is doing is just displaying all of the parameters here. For example, on the camera we have longitude, latitude, we have the range, all of these parameters are being here, and you have, as you can see here on the function, here, all of them. Okay, so it's basically just a look at for the camera display. Okay, so statistics overlay. So what is a statistics? Statistics is basically just the same as comparison. It's just with another balloon. It's basically when you go to a place, it displays a statistics camo. Okay, it's just a balloon. So this is just basically the XML. Okay, I also have the chromiums, but the chromiums are changed to another button that are also on the LG service. Okay, so moving on, we have country and point of interest. These are the models that are, well, I'm going to explain point first. So these are the models that, it's for the hierarchy of the application. This is just the application wise on how this is going to be, updated when you load in a screen and you have to see all of these things. For example, for the point of interest, it just has to store all of these things there. It just has to store, all of the coordinates. It needs to start to, the name. It needs to store everything that it has. It needs to store it here. Okay, so for the country, it's basically just the same. It's just storing the name, the flag, everything. But for the country, we need it here because we need to tell the point of interest which country it belongs to, Okay, so moving on for the screens, I don't really have to explain much for the screens since it's just, widgets to build, the application screen, the UI and everything. But, the About Us screen is just, the text for the About Us and everything, all of the images. The Connect screen, it basically just fires the SSH connection on the LG service, the method that is just for that, it has all of the inputs here. Let me see if I find them here. All of the inputs for you to introduce, and then it saves them, and it does recall them for the editor service method. Okay, the help screen is just text. The initial splash screen is basically, well, I have two splash screens, but one is not really a splash screen. I have the splash screen for when you load in your application. You can see that, well, it displays a white background, and then it has the logo image. Okay, so basically the other splash screen that is not really a splash screen, it's just basically the loading screen, for it. Okay, so well, the loading screen that I have set is basically here. It's just a loading screen that I had earlier, but then I had to implement the initial screen because that was the correct way to do a splash screen. Okay, deploy screen is just the displaying of all of the landmarks. Deploy detail screen is the one that carries all of the things. As you can see, it has like 1,300. Yeah, okay. It basically has all of the functions that are being on the LG. Well, yeah, mostly all of them, besides from the connection, obviously. It displays, well, the comparison, it does the fly to, it does the orbit, everything, all of the main features from my application are being fired here, because this is it's the one that has all the buttons for it, So, we can jump here. On the timeline, this is just the main screen. It just displays all the countries and everything. And here, well, I can say that here it also carries a external widget, which is basically here, that I did on the past. On the past I wanted to do more widgets to like make a better organization, but then I just did it on these screens. I just put it there instead of just making it like this because I didn't think it was necessary. Okay, so we're gonna jump in on the services. We're gonna go to API service. Okay, which this is basically just the management of the AI. So, well, when you do image generation or text generation, you need an API and you need a model to display all of this content. Okay, so basically this is just it's just a container for it, because, well, I have support for ChatGPT, for DALL-E, of course. I have Gemini, and I have support for Pollinations AI. Pollinations AI is the one that I use mostly because it's just free and it's just for everyone. I have it on my application that it's a little tutorial back there on the where you put the API. I have there like a tab where it has a little tutorial on how to have your own API and how to put the model. It's totally free, okay, but it has obviously a lot of limitations with the image because you can do some type of images, but it has a lot of models, so okay, so basically I also want to show something here on the prompt. Well, when I do the image generation, I have to put a prompt for it. I need to tell the AI, I need to tell them, I want you to do this, I want you to do this exact image. Like, you just can't do any image you want. So I put this prompt here, okay, for a high quality architectural environment estimation for the landmark name in the year, and also it also adds an additional prompt that I have put here for the input text that I have below the button of future estimation, because you can put an additive text for this prompt. So for example, if you put in this additional text, make this building transparent, and then it does in the image, it puts the image transparent because you have put it in that additional prompt. Okay, so moving on, we have the font manager. Well, this is just in my settings tab. You can set the text of the application, all the text that is there. You can set it to be small, medium, or large, depending on your resolution of your phone. Okay, so this is just basically to store it on the DB helper. The language manager is basically just the same. The functions are down here, if I remember well. Yeah, this is just to save the translations for when you put it on Spanish or English. And here, up here, all of the translations for my application, because I have them hard coded, because I don't have any generation of the AI to translate everything. I can just hard code it here and it, you know. Okay, we're moving on to energy service. This one is the one that has much of the content of my application, because this class is the one that has all of the functions of that is being displayed on the Liquid Galaxy. So it does all of the commands for it. It has all of the HTMLs, and also, well, I'm going to explain. First, we have the SSH connection. Okay, so this is what basically fires the, let me see if I see it, the connection screen. I don't know where it is. Here, the connect screen. The connect screen fires this method, which is being the connect method for, you know, it does some commands, and then it does for the input that you put in there, it basically just stores it in there and it checks if the connection is correct, and if it does, then it sends the SSH. Okay, so I also have the balloons for everything. I have the balloon for the comparison. I have the balloon for the statistics here. Also, I don't have the balloon. Well, I don't have the balloon. Sorry, I have the chromiums. The chromiums, like the HTML. Let me see if I find one. I think this is the one. Yeah. See, the statistic HTML. This is basically just the, you know, what I said earlier. The chromium for each one. Okay. I also have well, the LG tools. Basically, well, relaunch, shutdown. You know, all these things. Okay, it's just a little bit of commands to, you know, make the machine know that you want to do something. Okay, so, well, oh, I also have, that I didn't add in here in the camos, I also have the 3D, I have the 3D display on the Liquid Galaxy here. I have it here. I didn't make it right there. I did have it earlier. I did put it in a separate class, but then it didn't really work at the start, and then I just put it here for debugging. It was really better, so it just left being there. Okay, so moving on, we have the POI service. Okay, basically what this does is okay, so the landmarks have a lot of information. It has a lot of information that is being sent to the Liquid Galaxy, and all this information is being stored in these JSONs. These JSONs have, well, it's 3 because it has all of the languages, but as you can see, it has all of the information of everything. You know, the name, the description, the statistics text, the present, past, and then the summary. You know, it has all of these informations, you know, and then when it has all this information, it just sends it to the POI service. It sends it to the POI service, and then it stores it there for it to be displayed in there. And also what it does, besides from the JSON, it also stores the coordinates from each place, because each place has a coordinates to be able to do the flight to. Okay, as you can see, it's in CSV that I exported from my Google Sheets. Okay, so let's move on. The time manager is basically just, so when you move on the application, you have set to be in past, present, and future, and you can basically just set each one of these things. Like if you're in future, so it doesn't change when you get to another place. You know, it says the time that you are in here. Okay, moving on, this is just a notification. The notification is basically for, you know, it's just a pop-up that appears when, for example, if you connect, then it does like a successful connection, and then it says you successfully connected. Okay, and then you can just scroll down to, you know, erase it. Okay, the logo panel, I think I already explained this, is just for, okay, in the main screen, you know, you have the logo up there. So this is basically just the container of that widget. It's basically just that. Okay, so I think I explained everything, so we're gonna jump to the personal experience.
Started. 1882. Architect. Antoni Gaudí. Style. Modernism. Original budget. Humble donations. Status in 1900. Only nativity facade started. Started.
Let's have a bit of fun till I downfall. My love, if you feel like I do right now, don't say you're on the run to the other side, my love. You say you wanna try, but you never do. Sugar, there's a reason why we lose. You say you wanna cry, but you never do. Sugar, there's a reason why we lose.
So, for my personal experience this year in Google Summer of Code, I have to say I have learned a lot, especially in Flutter framework, since I had to do a lot of coding and a lot of help from the AI. So, also from the Flutter, I have had a lot of issues, not from the code itself, but from painting things on the Liquid Galaxy. Okay, so I had a lot of challenges and issues. For example, painting the KMLs. Painting the KMLs was really challenging. For example, something that was really easy was just painting the logo, which it was just an overlay over the screen of there. It was pretty easy. But things that were more challenging were, for example, 3D KMLs, which I had to do on this time. And basically all of the issues that I had is that it didn't paint at first. And when it did paint, it didn't paint on the master. So I had to implement another method for it. I had to implement another method for painting just the master and then the other slaves. Okay, so basically I also implemented an AI implementation for my future estimation, and I have to say it was pretty easy. It was more easy than painting the 3D KMLs, because the AI implementation that I used, well, it was more challenging finding it than implementing it, because when I already find it, it was like just a few days that I implemented it, because it was really easy, because that AI already had like a library for the Flutter, so it was really easy. I only had to implement the API input and the model. Okay, so the AI was not really time consuming, as I said, because it was more the KMLs. The balloon, for example, it was pretty easy. I had to say, as I said earlier, it was mostly the 3D. So my experience was really good. In summary, it was really good. It was really fulfilling, because I had to learn a lot of Flutter and a lot of coding, and it was just really fun testing it on the Liquid Galaxy, seeing all the errors and all the challenges. It was really fun to do. So this is my demo app presentation. Thank you all for watching, and I hope you enjoy Liquid Galaxy Time Machine. Thank you and goodbye.
Hello everyone, my name is Alfredo Bautista, one of the mentors of the GSOC 2026. I am Flutter and Dart Google Developer Expert, and I want to use this video to share with you my experience as a mentor this year. I am in Austria enjoying this amazing landscape, but I want to take like a few minutes to share with you my experience in this video. So first of all, working with Jan was an amazing experience. He is a very dedicated student. He was very deep into the Flutter framework. He was learning a lot of stuff in this period, in this summer, understanding how to build an scalable app, how to build different widgets, different screens, and even more connecting with different providers using API. We decided to introduce a little bit of AI generated features in their app, and Jan was an amazing student, like researching different providers, different pricing for the application, and it was very nice. Also, like the flexibility to inject your own API to use in your projects. So basically, it was an amazing experience. I recommend you to visit our Liquid Galaxy store to see all the apps and all the projects that we run in this summer. I really love to mentor this kind of people, because you can see like the enjoy, you can see like the happiness building something in a summer, and also you can share your knowledge with this student. So it's like a very grateful experience. So it was very nice for me. I will love to repeat again next year in the program if it is possible. Yeah, I recommend you to see all the videos from the other mentees to see, and the mentors, to see their experience. I want to say thank you for your time. I hope to see you soon in a different event, different videos, or in a different community related stuff. So enjoy the day. Thank you so much.
Hello everyone, I'm Kabir Singh Khanuja, a third year computer science student at Vishwakarma Institute of Technology, Pune. Well, it feels surreal to, tell that I'm in third year. I was in second year when I started contributing to this organization, and it's been a journey. Well, this summer I had an incredible opportunity to participate in Google Summer of Code 2026 at Liquid Galaxy project, where I built AI2 Director, which is an omni-agent system that transforms a simple text prompt into a fully cinematic, immersive geographical tour across multi-Liquid Galaxy rigs. The idea is simple but powerful, that you can just type in, historical forts in Rajasthan, or the wonders of world, and the app does everything for you. You have an immersive cinematic tool ready. So let's get right into the code part of it. All right. Okay. So let's understand my app in a deeper way through the code, right? Now, there are a lot of files, and this whole repo is kind of heavy with files. So I've kind of divided this, or I've kind of made this whole repository modular, because for each and every function I've created a particular folder for better readability, and I think it also follows one of those solid principles. So whether that might be any LLM function, or it's a Dart service that is related to KMLs, right? So I have made a folder for that. Again, it points towards making it being completely modular, right? So without further ado, let's get started. This is main.dart as LG AI2 director. It's based on Flutter, so that's how the app starts, with main.dart. And I'll just walk through this, but there are 10 files that I've opened, which are, I think, the core of the app. Without that, the app wouldn't exist. Well, there are more files than that, but those 10 are pretty significant that way. So yeah, this is the main.dart. It initializes. I have different languages. Okay, so it's a multilingual, it has a multilingual functionality where I can change languages. So that's what I'm doing there. I'm also really proud of this theme mode. Other than the fact that it does support a lighter dark mode, it does recognize or perceive which mode the OS is natively using, right? So if my phone is always on the dark mode, that's the system's default mode, so it would guess and it would just take up that mode, and then you can of course change, right? So that's that. So that's main.dart for you. App router is again one of those hard components in hard, which are important for the routing. I have 4 major pages that are there. There's the home screen, right, which you've seen a lot of times. I'm gonna show you that later in the video. Then I have my saved screen, where I have the option to save the KML and I can replay the tour on LG. And then I have my tour screen, where I get the history of the tour, the locations that I've been to and everything related to that. And then there's basically a profile screen. So in the profile screen, I have the help screen, of course. If anyone wants to know about the documentation or about a particular functionality of the app they're not able to understand, they're gonna get that there. And then there's about screen again, a little credit and stuff. And I have a nice little drop that comes up for the settings part. I could have had a traditional settings page, but I was like, let's go a little modern, play with the material 3 guidelines. I want to jump mainly into generation screen. Right now, again, it's the AI2 director. I'm generating locations, different locations are being generated, right? So this is the source of truth, or kind of the orchestrator of the whole thing, right, of the whole app per se. So when a prompt is submitted, right, it basically goes to dash generate. It basically calls that, right, it first calls the extract locations, which basically is here, extract yeah, yep. So it's gonna call that, and then it hits AI, and then it returns the tour objects, right, 2 location objects. And this then would put you into a particular kind of a loop where you're gonna this so again, there are 2-3 things that are happening. Firstly, you're getting the coordinates of the location. That's mainly important. And then you get the details of this location, the address of the location. So if supposedly it's Red Fort, what are those coordinates? Then where is it exactly situated? That's important. And then I'm also getting the media. You're gonna see the KML balloon having the images, right? Also in the app, you're gonna find images. So these are the 3 things I'm inculcating in that loop itself, right? It resolves it. And then it has immutable constants, where it won't change. It would just always be there attached to it. And just in case if it's not able to return anything, right? So what I do is that I'd rather show a landmark without coordinates than to lose it. So that's it. So yeah, and then when basically the list is ready, then It basically has all the valid locations that are there, and then it goes with a push replacement this thing. So then you have a preview screen that you'll see again in the demonstration. Then I have LLM client. Now this is the actual AI integration, something I wanted to be in the agnostic terms rather than native terms. So it's basically provider agnostic. Bring up any kind of an LLM provider, might that be Grok, might that be DeepSeek, might that be anything together or something, or even your local models. You'll be able to run it, right? So the generate, I have a generate method here. It basically oops, it's a generate method. Yeah, there's a generate method which basically sends a post request, right? And it uses the OpenAI's basic convention, which is always there. That is the base URL, then you have the chat, and then you have the completion. And of course you're gonna have your messages where you have a role, because something that I'm gonna predefine in my system, the prompt that I have, which is this thing, right? And something that the user is gonna put in, right, as a user prompt. And then I have a temperature as well. So this is a pretty standard OpenAI thing that they have given, I think back in 2021, 2022. I guess I am wrong with the dates, but that's what it does. And you can put your API key in here. That's how it takes, right? And it never leaves the device. So I'm also inculcating the shared preferences in here. And then I pull out the text with this thing, right? This is the final content that I'm getting. As the choices and the message and the content, right? And if the call fails, I convert the DO error into a friendly kind of situation. The model had an empty response, or try a different model. You might even have your credentials that are not incorrect. So I just pop up that message, which is important for the user to know, right? So that's basically all about the LLM client. Then again, this is the prompt part. This is the whole brief prompt that I've put. It is just not 2-3 lines of prompt, because there are certain things I wanted it to act a certain way. So this was important. And then there's geocoding. Now geocoding is where a lot of mistakes happen, and hence I wanted that it has that reconciliation system in itself, right? So I made it resilient. So basically it gets coordinate, right? Wait. Yeah, so there's this get coordinate method. Again, all the methods that I've defined, I've just defined the way I speak, right? And it first calls this location query variance, right, which kind of generates progressively a cleaned up version of the name. I had some problem with Las Vegas's location where I had commas and parentheses, so I kind of clean it up, right? And then it loops it through, and then each loop goes through the lookup, right, which tries to access the platform's native geocoder, right, which is your location from address, right? Location from address. This is your device's native geocoder, right? And again, if it fails, then I'm using OpenStreetMaps or Nominatum, which is this one, right? Only if it fails, right? And this basically happens if you're going to use a web controller, but it doesn't fail generally. One of the main parts of the whole app is the AI film in itself, right? So this generates the AI film, right? It's the interesting part, and it also handles the failure, right? So for each the cinematic building that I do, build cinematic prompt, what happens is it builds a camera directed position, which is, again, I feel it's a little important for what it is. And it generates the clip, and then it builds it together. But what's important is that it builds all the videos separately. So I'm gonna have like 5 to 6 videos for 5 to 6 locations, so it has to also stitch it together, right? So I'm using video stitcher, that is FFM, this thing, yes. So what it does is it's stitching all the videos together, and then it is copying that into your local path, which is also gonna be in the gallery, right? And then it formulates the whole video which you are able to see. and the whole logic of that is basically written here. The way I'm waiting for it to come, and then I'm able to concatenate and then produce it onto the final path. Okay, so here we are in the most anticipated part of the video, the tour, the app itself. I'm starting the app with a pretty little, splash screen, which is also a logo that's available on the leftmost rig, and you have a nice little video that's there near the footer. I've added that to know how the film is, once you're gonna generate that. So let's start with the tour real quick. Let's go to most fun places for vacation in Asia. Okay, so now it's gonna fetch as the flow goes. All right, so it has tailored a nice little tool for us. We can go and inspect particular locations. We can see, we can move around. The app itself, we don't really have to, explore this through the LG rig, and we start the immersive tour. Do we want to film? Yes, we do want to film. There's some error. We'll go to the film settings. We'll see if it's correct or no. We'll save the configuration and then we'll start, and yes, make a film. Okay, it's verifying. It has verified, and now we'll also have a pretty little film for us. Okay, so on the rig, it's now going to that particular location. Okay, this seems interesting. Okay, so I'll start the narration.
Angkor Wat is the largest religious monument in the world, built in the 12th century by King Suryavarman II. Its intricate
Amazing. I have the option to turn off the narration if I want to, and I can skip to the next location as well if I want to. You see it gets a little cut there, but the camel balloon, it's perfectly fine on the Liquid Galaxy rig side. Okay, so this is the next location, that is Great Wall of China, and it's gonna get updated on the app itself. All right, so it's updated on the app. I can basically pause it and I can go in this. Now this is in sync with the phone. I can go move around locations. I can see what this particular part is. So I'm just, flying over to that particular part from the location, and that's how it works, right? So this is the whole tour I'm gonna get. I'll end the tour for now. But okay, I want the film to be there. So okay, let's wait for the film to get generated. Okay, so here we are. The AI film is generated, and let's just go and play the video. Okay. Okay, so here's the AI film that is ready. Oh my god, this looks interesting. You have all the visuals. It's a little cinematic that you can visually imagine, right? So, and then you can share this with anyone, and it's gonna be seen here. You can go and explore all you want. All the information is here for you, all available, and you can even see the history. So that's tour director for you. Thank you so much. Well, this was one of those most, challenging and rewarding things that I've ever built. So going into GSOC, I had never worked with Liquid Galaxy, never written a single line of KML, let alone deploying anything to a physical multi-screen rig, that over SSH, right? But after months of understanding, grinding, contributing, breaking down, I've now built a fully production Flutter app that controls the hardware in Spain from a phone in Pune. I mean, not literally, but you get the point. So the biggest lesson that I learned was that hardware really humbles you. The things that work perfectly in my VirtualBox simulation would behave completely differently on the actual Sony screens in Spain. So lots of ups and downs, which also made me close with my fellow contributors, the kind of talks we had. And I also got to give back to the community. So I was able to write a universal LLM integration guide that any future Liquid Galaxy contributor can inculcate that into their project in minutes, regardless of the AI provider that they use. So that was fun, and working with Andrew, Yash, Vedant, that was fun as well. The whole Liquid Galaxy team, this has been genuinely inspiring. It was one of a kind of an experience, and it's open source at best. Peace.
Infinite power, infinite power, infinite power, power, infinite power, infinite power, infinite power, infinite power. Infinite power. infinite power, power, power.